Hi, this is stream number 279. I just was thinking about how I've forgotten to upload my streams to to YouTube, and I need to do that because they're going to expire, and I'll have to then re-upload them from my own local storage, which is a pain because it's uploading gigabytes of data. Anyway, so yesterday I started working on this program called Moon Count, because Lua is Portuguese for moon, and I'm using the Lua programming language for my game scripts, and I want to instrument them to measure how much time they take and what functions call what other functions to try to find bottlenecks in my game scripts. And the program, well, it's actually a library, Moon Clock. It's sort of like an add-on to Lua that when you enable it, it's supposed to find all the functions you have in Lua and wrap them to start measuring time and number of times you've called it and that kind of thing. So I didn't get to actually instrument things yesterday, but I got very close. And after the stream, I worked on it a bit more. There were a couple things from yesterday I was trying to figure out. So one of them is how to implement this in my instrumentation code. Basically, given a function foo, that you could say foo equals instrument foo, and then instrument would take your function and add like start and stop timing around it, wrap that up into its own another function, and then set that to be the foo, so that when you call foo, now it starts timing, calls the real foo, and then stops the timing. Hey there, Nui. How are you doing? So I didn't know how to do this. I know Nui was helping me out with some pseudocode, and I did some research after the stream, found out how to do it. It's called Lua push closure, and then Lua up value index to get variables. So if this is a closure, actually, if this is the closure, so to speak, the variables available are fn and name, for example. Then if we're using fn and name here, in the C API for Lua, these are called up values. And the way you would create this function is by doing Lua push C closure, and then you have to have the variables that you're using from the closure on the stack, and you say how many there are. And then when you actually use them in your C function, you get to them using Lua up value index. So the equivalent of this instrumentation function in C looks like, drumroll, looks like this. Instrumentation factory. So this is a little too wide. I want you to see all of this code. So roughly, this should look like this because it's a function that returns another function. So this whole thing is a function, and it's returning this other function. You can see that here where we're making a closure and returning it. So this 3 means we're capturing 3 things in this closure. We are capturing the inner closure. So there are 2 functions, right? This outer one is also a closure. So we're capturing the inner one, and then we're capturing the 2 arguments. In the inner one, I think we only needed to capture... No, the inner one captures all 3. The outer one only captures the... Oh, right. It's hidden here. So rewind. The only 2 things written here that are actually captured in the closure are a function and the name, right? But there's a third thing I needed to add. It's this game thing. So it's the instrumentation context itself. So in Moonclock, it's just going to be Moonclock, and within here, I'm just calling it self. So we're making a user data just to hold on to the pointer to our own implementation. And then that user data is then captured in the outer closure, so that inside here I can recover it by saying up value and then getting access to the impl again as self. And that's how I am basically going to do the instrumentation. So the inner closure needs two other things, the function and the name, and so those are these two things. That thing... No, hold on. See if I get this right. Right, so when the function is called, it'll have two arguments, function and name, and then we're adding on top of that the self. So then there are three. That's what this 3 is. So it's going to capture the two arguments plus the self into the inner closure. And it's a little funny, the up value indices. So it's the first one you push is going to be 1, the second is 2, the third is 3. So if this function here is given two arguments, function and name, that means function's index 1, name is index 2, and then this user data ends up being index 3. So that's why that's a 3 there when we're getting the self. And I think I might have switched it so it's actually name, and the name became the path because I wanted to get the entire path through the hierarchy of tables. Let me verify that. What's the order here? Yeah, so I switched it. It's path name. So maybe I should just update this. Path name to be consistent with my code. And path function, sorry. And then the path is used, the whole path is needed for the instrumentation. So that's up value 1 is the path, function is up value 2, and then the instrumentation context, the impl is up value 3. So path, function, and implementation. So what we're doing inside of the instrumentation is we're getting access to the instrumenter, getting the path into C++ so that we can make a string out of it. And I'm just basically the instrumentation right now is to just report that we called it. Hey there, Manez. Manez? Is it? I guess it's Manez. I keep saying Manez, but it should be Manez. Right, so right now the instrumentation is just reporting the function you called, just to get through the test. And but we still need to call the original function. So this is a little trick where get top tells us how many arguments we were passed. So we collect that as number of arguments. And then the protocol for calling is you first call the function, so that was of value 2. And so it needs to be at the bottom of the stack. And then all the arguments are above that, and then you call it. You tell it how many arguments are, and you use this special value for the number of return values expected. That tells Lua that I want all of them that I get. And Lua call will pop the function and the arguments off and push the return values. And so, again, we use this get top trick that tells us how many return values there are, and we just return it. So this whole thing right here is the wrapper. This part is the instrumentation around the wrapper. It's like so Manez, but okay, Manez. Anyway, so I figured this out post-stream yesterday. I wanted to go over it now. The magic was push C closure, and then the third argument to push C closure says how many things on the stack do you want to go in the closure, and you can put whatever you want. So that's how that's what Lua actually ends up doing behind the scenes when you do something like making a function that accesses variables that are not arguments. It says, oh, that I need to capture that as an up value. So internally, it's going to push the path and the function onto the stack, and then make a C closure, make a closure, which is just a function that uses those up values. Sure, you can. Raimu, Rich, Richard. It's all good. Let's see. Just don't call me late for dinner. That's how the cliche goes, right? Call me whatever you want. Just don't call me late for dinner. All right. So I got this working in the sense that the test... Little reminder of the test. The test calls foo, then starts instrumentation, and then 3 times calls foo again. stops instrumentation and calls foo a fifth time, and we expect we only get 3 report lines because we should only get report lines while it's being instrumented. So in reality, we're getting 4, and that's because stop instrumentation doesn't actually do anything. So this 4th call ends up being instrumented. Where'd you get the name Raimu? I have a command for that. Oh, but I have to be running my bot. Let's run the bot. Here, I will do what the bot would have done and just copy paste the command result. Oh, wait a minute, I don't have a command for that. I should probably make a command for that. Yeah, so why Raimu? It was a name that stuck with me when I was playing World of Warcraft with friends, and I didn't know what I was doing way back then, or what names I should pick, so I just let World of Warcraft pick a randomly generated name for my character, and it was Raimu. And then everyone was calling me Raimu. In fact, when we'd have meetups in real life, they call me Raimu, and that's the name. I just couldn't get rid of it. So I'm like, okay, I'll just use that as my online name now, because before that, I didn't really have a good online name. I'm bad with names. What can I say? So so if I was to make a command, let me do this right now. Add command Raimu. The name Raimu was originally the randomly generated name for a world of, I had to spell world correctly, Warcraft character. After IRL friends started calling him Raimu, after IRL friends who played WoW with him started calling him Raimu. Actually, let's say after friends who played WoW with him started calling him Raimu IRL as well, the name kind of stuck and became his online name. There we go. So we'll have the bot echo it back. Name Raimu was originally a randomly generated name for World of Warcraft character. His friends who played WoW with him started calling Raimu in real life as well. The name kind of stuck. It became his online name. There you go. My stream helper is not actually showing people in chat. That's weird. It's showing chat, but it's not showing joins for some reason. Let's start the view timer anyway. I'm gonna have to remember to who I need to wave to. Hey there, Toulouse. Whoa. Chat jumped while I was doing the menu thing. Hey there. Hi. Okay. So what I need to work on first today is to get the instrumentation to remember where the original functions are, so that when we call stop instrumentation, we can restore them, basically strip off the wrappers, so that when we call foo a 5th time here, it doesn't end up in the output list. So that's what I'm going to do. The code that's putting the wrappers in place is here, where we're going through all the functions that, where is it? Find functions in composite Lua table, which we got working yesterday, finds all the functions, and we're going through them all and making wrappers for them. So this is look up that function's information. This is construct a wrapper for it, and this is find the table the function is referenced from and replace the function with its wrapper. So before we lose access to the function, I need to actually stash it somewhere. I'm thinking of actually just stashing it back into the original functions table and then holding onto that functions table in a special registry location in Lua. So Lua has this concept of a registry. It's kind of like global variables for plugins. So you just say Lua, hey, I want a registry location, and it says, okay, the next one is this, here it is. And then you can put whatever you want there. So I usually just make it a table and put stuff in that table. And then you can get back to that registry location whenever you want, as long as you remember the number. And we keep the number in our C++ code, so we can get back to that Lua table whenever we want. And then when you're done with it, you tell Lua, okay, I don't need that registry entry anymore, and it goes and destroys everything. 95 bits for 2 euros? Wait a minute. Shouldn't you get 200 bits at least? No, you don't need to give me bits. That's okay. Moths fly out of the wallet. Don't lose your wallet to moth holes. Actually, what would be worse is if the moths eat holes in your wallet and the money falls through the hole and you lose it. Feels bad, man. Yeah, I don't need bits. I'm very appreciative of all the support I get, but I don't require it at all. Let's see. Yeah, I think this functions table, in fact, this functions entry, we can just stash the original, well, actually, it already has the original function, so I don't have to stash it at all. I just need to stash the functions table itself. So let's do that. Let's stash the functions table itself. So I did this registry stuff before. I just need to find out where I did it and copy it, what I did. Lua new registry. I need to find out where it is. Maybe it's Lua registry index. Okay, I can't find what it is. Let's just look for registry. Pelman? What's Pelman? It's dumpling in English, but it's a bit different. So, okay, yeah. I know that there are lots of varieties of dumplings, so it depends on what you put in it and what the shell is made out of and how you cook it. Sounds yummy. Making me hungry already. Okay, I did this in runner, I guess? Yeah. So we'll have this variable, just like we had in runner. Let me pin runner. And put this in the instance for the instrumentation. Where did I put that? Oh, down, 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 down. Here it is. This is the registry, Lua registry index of the table. So this is, so we just say this is the Lua registry index of the table of instrumented functions. And let's say, let's just call it that for now. That's fine. And then that's how we get access to the table. We would do raw get I with registry index and then our variable. How do we create it in the first place? It's Lua L ref. So we have the table on top of the stack and we call that. So let's do that. So, where's a convenient place to do it? Actually, right here, because we have it on the stack, right? Right here is probably the best place. So we'll do this. .get. I had to add these .gets because we're sharing the Lua interpreter with whatever is using the instrumentation. Whatever's using Moonclock is providing us the Lua interpreter. Let me make sure I'm doing this correctly. It's Lua L ref. Lua L ref creates and returns a reference in the table at index t for the object at the top of the stack and pops the object. A reference is a unique integer key. As long as you do not manually add integer keys to the table, Lua L ref ensures the uniqueness of the key returns. That's how we can share the Lua registry with other plugins, is if they all agree to use the registry this way, they all get unique keys, and so they don't collide. So when we're done, I think we call Lua unref, right? Yeah. So we're gonna hold on. That pops the functions table. So we'll end up with just the instrumentation factory at the end. So then we just need to pop that to make the stack empty. So there we go. We've held on to the table. So in stop instrumentation, we can get the table back by doing this raw get I. So we'll do that first thing. Lua get registry index, Lua registry index, and now on the top of the stack again is magically the functions table. Yay! So then we'll loop through it again and pull off the wrappers and restore them. Oh, before I do that, let me update the test. We should make sure when we call the uninstrumented foo that it actually works. So inside this loop, I was checking to make sure it worked by pushing a number and then making the call and expecting a return value, and then expecting double the number, because we made the foo function just take the first argument on the stack and multiply it by 2 and return it. So we can do the same thing here. I can say like Lua push integer Lua 42 and then expect equal 84 for Lua 2 integer Lua -1, Lua pop Lua 1. So we're calling foo with 42 as the argument. So one argument, one return value expected. So it pops the function, the argument, and pushes the result. We take the result off the stack, make sure it's 84, and then pop it. Right? So let me make sure that actually, that expectation works. Yeah, so it worked. The only failed expectation is that we should only have 3 instrumented calls, and there are 4. So now we're going to uninstrument everything. Basically go through the table again and pull out the original function and assign it in place. So it's actually going to be kind of similar to this loop, only we don't have to make an instrumentation function. So we get the registry, then we get the number of functions, look up the function's information. I need to get the path of the function to know its name. So let's close this so everybody can read it. So get the path out of the functions table entry. And I don't need to do this instrumentation factory thing, right? I think I just need this stuff down here. So it's different from that point on. So if I'm getting the length of the path, that's the length of -1, so that's that, and then the rest of it is this. I should probably try to think of a better way to document what the expected Lua stack state is rather than having it all in one line, because the lines get really long. Okay, once we have the length of the path, I want to fetch that one. So that's what this raw get does up there. So I want to, the key is pushed on the stack, and then this is the table index. Where's the table? That's at 2. So this part of the stack is the same. The length of the path is replaced by the entry at the end of the path. That's the name that we want. Then I gotta get right, then we're done with that, right? Now we need to find the table containing the function and reinstall the original function without its instrumented wrapper. Does the instrumentation factory exist in that stack? No. Oh, you're right. Yeah, thank you, Toulouse. That's just a copy-paste problem. It's only functions, right? So all of these go away at the end. All these go away like that. Thank you. Find the table. Okay, so get the table. Let me make sure this is the right stack. It's not, so I need to fix some of the stack indices. So where is the table? It's actually, I don't need the path. Maybe I pop the path off to simplify things. After we get the name, we can remove the path part, which is at -2. So then we clean the stack a little bit. So -2 is now the table entry. Okay. And yes, so this path is not here anymore. Some of these are going to be wrong, but we'll fix them. So it's, the numbers are wrong here. 3, 4. Your biggest project is an interest calculator in 2 languages. You're still damn proud of it? It was your first month when you made it? Nice. Well, thank you, Manez. If I'm any good, it's only just because I've been doing this a long time. I try really hard to stay away from egotistical thoughts, though. I try to remind myself that I'll be learning constantly until I die, just like everybody else, and never fool myself into thinking I've reached the top of anything, and just try to stay humble about it. I think that's the most healthy way to approach life. But, you know, I appreciate the compliments, of course. I think in the past I would get too full of myself and too egotistical, and I don't want to do that anymore. It's 3, right? We're fetching the table key out of that table. So then we end up with that. Let me fix this one. No, we don't have the table anymore. Right, so it's just functions I+1 dot table. You're 12? Oh, that's right, you're pretty young. I wish my son, who is 13, I wish he was able to write an interest calculator. That's pretty good, actually. I'd be very proud of you for, well, I'm very proud of you, but I would be proud of my son if he could do the same thing that you could do. It's a natural trap to fall into when you're younger, though, to start to get egotistical, and because our society is competitive, right? And so you want to kind of show that, hey, I'm on top of the, you know, I'm better than the people around me, that kind of thing. That's just our competitive nature. And in certain contexts, that will work. Like if you are marketing yourself, trying to find a job, do that as much as you can. Brag about yourself. Say, I'm the best at what I do, because that'll land you a good job. But in other contexts, it's just not polite, right? Yeah, man. Knowing multiple languages is just really cool. I wish I could do that. I studied French for like 6, 7, 8 years, and I forgot most of it. Went to France and felt so embarrassed that I couldn't remember how to speak it very well. If you don't use those languages, you lose them. Unless you learn them really, really young, I think. Okay, I don't need to do this part. We've already done that. Let me just... Knowing where the table is and knowing the path and the function... Actually, did I lose the function? I never looked it up. We need to look up the function. I actually want to flip these because I want the path... Actually, you know what I can do is I can look up the path, then look up the function, and then put the table at -3 and then do set. That's what I'm going to do. So let's put those in front. Look up the function. Then look up the table. So this is inserted there. And let me fix up the numbers. Sorry, I see that there's chat in the corner of my eye, but I don't want to mess up here. So let me finish doing this and then I'll go read chat. Function and then table. So that's the table, that's the key, and that's the value. So I need to put the table, I need to do insert 3. Lua insert, Lua get -3. And this number is probably wrong too, right? Right, that should be a 4. Then when we reorder it, so -1 is -3 now. That goes down. These two move up, and this one goes here in its place. Okay, let me read chat. You know Estonian and English because Estonian you use all the time. You were born and raised there. Yep. English. It used to be French was the international language. How did English supplant French? Russian is basically a native language because 30% of your country are native Russians. Makes sense. I guess it helps to be in a country where there's a lot of different languages close together. So in the US, if anything, I should know Spanish because I'm in California and we live close to Mexico, but I don't. My kids do a little bit. But yeah, I think we're at a disadvantage in the US because geographically we're very distant from anyone who doesn't speak either English or Spanish. Okay, so it's at the right... Okay, so it's just set now. Lua raw set. Lua.get -3. And then that drops those two from the stack. And we're left with those 3. And then I just pop 2, right? To get the functions back only. Okay, did I do this right? Let's review. We start with the functions table. We're going to loop through it. We get the number of functions. For every function, we get the index, add 1 because Lua starts at index 1 and not 0. We look up that entry in the table, which is itself another table, which has a path, a function, and a table in it. And given path, right, so we look up the path, and then we get the length of the path and find the last entry of the path, and we drop the path part. Then that's where we know that the function's name is. And then find the table containing the function. So let's find the function and the table containing it. And reinstall the original function without its instrumented wrapper. So get the function, get the table, -3, -3, -4, -4. Yes, -3 and -4 are where the function's I+1 table is. Then move the table to the 3rd position in the stack from the top. And the 2nd position is the key. The 1st position is the value. So raw set -3 will put the function with that name back into that original table. And we're left with the table, the functions entry in the functions table, and we drop the top 2. We're left with the functions table alone, just like at the top of the loop, and then we loop. Looks good to me. One thing I forgot is, now that we're done with the registry, we can unreference it, because we don't need it. So lua l unref. Let me make sure I do this right. Okay, I have to repeat this stuff. Like that. And I suppose we should do the right thing, which is to make that... put it back to 0 would be a good, smart thing to do, right? And then, you know what we should do? We should have a little safety check. If it's 0, then just return. It means we're not instrumenting anything. And similar thing, if we're already instrumenting, we shouldn't do anything either. So that if that's not 0, return. See? Smart! Alright, I got it. Going back to chat. Weird question, but your thoughts on Miracle Whip? It's good for certain kinds of pies, I guess. When you say Miracle Whip, the first thing that comes to my mind is pie. Is the whipped cream that comes out of the air compressed canisters, is that also Miracle Whip? Because my kids love putting that on stuff. And it's sort of a fun thing. It's good for nothing? What? Good for pies. Come on. Pumpkin pie. I don't think it's a mayonnaise substitute. Mayonnaise is more... So Miracle Whip has got a lot more air in it. It's like more poofy. Mayonnaise is more like a saucy thing, right? I don't think that they're a substitute. Where at least where I am, it's. You want me to Google it? Mayonnaise substitute? Okay, we're gonna look this up. It's a sauce condiment. Really? Okay, that's not the kind of Miracle Whip I'm used to seeing. Maybe I'm just confused. I'm thinking about the stuff you put on pies. What is that? Whipped cream. Not Miracle. Let's say whipped cream. No, not of some kind of weird video. Yeah. Okay, I'm confused, mayonnaise. So what do I think about Miracle Whip, the mayonnaise substitute? To tell you the truth, I didn't know it was a substitute. When I see that can, I think mayonnaise. Is it? So it's not mayonnaise? Oh. That's sneaky. I've been indoctrinated into thinking it was mayonnaise. It's not, huh? What is it made out of? Water, soybean oils, sugar, vinegar, starch, eggs. I mean, it sounds like it's the same kind of stuff that goes into mayonnaise. Look at history. Yeah. Huh. Advertising campaign. Interesting. Well, they fooled me. Certainly fooled me. So how do I feel about that? I don't know. I guess I don't feel as strongly about mayonnaise as you do, mayonnaise. Cool Whip. That's what it was. Yes, that's why I'm confused. Cool Whip. Yeah, exactly. That's what I thought. So, it's the whip part that got me. Cool Whip. Yes, my kids love that. Put it on pies. Thank you, Toulouse. I'll give you another point for helping me remember that. Good for nothing. Yeah, well, if it's not mayonnaise, I don't think mayonnaise we should use it, right? Okay, unreference it. Let me run my test now. Hey, look at that. We got it to work. Nice. Okay, let's check that in because all the tests are passing now. This is moon clock. So we are successfully unregistering. So implement stop instrumentation. Okay, so right now the instrumentation just records what functions were called in what order. That in itself is kind of cool, but it'd be nice to have it also measure the amount of time it took to do things. Miracle Whip was made as a cheap alternative. Yeah. Well, I guess what we call what my family calls mayonnaise would include the heretical Miracle Whip, but that's because we've been fooled by the man. Yeah, that's it. We've been fooled by the man. Do you have 150 points? Oh my goodness. That's top tier now. Okay, so I want to do more than just print out the what functions are called in what order. Right, so we did that. That turned out to be super easy. We already had the table. We just stored it in the registry. This I just did. Okay, yeah, I wanted to do this at some point. Maybe not yet. Let's save this for later. I'm going to need to do this because a lot of my game's functions are not in a table, they're in a user data. And as long as I make the user data implement the pairs meta method, then we can list those functions. Actually, it has to found in values that have the pairs and new, I guess it would be pairs index and new index meta methods. Because if we can't use the new index meta method, we can't instrument it. And I'm throwing index in there because... Why? Maybe we don't need the index. Where do I call raw get? You have 2 points there because you signed up. Should I be giving you another point for the interesting discussions about... Hey, you've been a pretty good contributor to chat. We'll give you a few more points. Points. I'll give you 3 more. There, now you have 5. Because you're contributing to chat. Even if it's a little bit off topic, it's still interesting. Just don't make it so much off topic all the time. You know? Because I can't get too distracted. I have to remember, I'm a juggler here. I'm balancing in one hand code and chat. So if chat gets a little too far away from my code, I'm gonna drop them. Oh, hey there, A squared. I didn't see you. My stream helper is really far behind. I wonder if Twitch did something with how it shows who's in the chat room. Because it's taking like many minutes now for people to show up. Either that or everyone's marked as a bot. Yeah, we're outnumbered by bots here right now, apparently. Should I say hi to the bots since they outnumber the humans? We do a bot shout-out list. Here, we'll list all the bots here. So, hello, Omniarania. That's my bot. Hey, Stream Elements. Hey, Tobdum. Alfred Judicus. V&K. Windsock. Virgo Pros. Digibot. A10. And my favorite bot of all, Commander Root. We shouted out all the bots there. I feel we're outnumbered by bots today. Always outnumbered by bots? I hope not. That's sort of be a sad thing to always be outnumbered by bots. Yeah, my viewer count is extremely low today. Is it because it's Friday and it hasn't yet struck the 11 o'clock hour for me? Maybe no one wants to see Lua. You know, I don't blame them. Lua is a little bit weird and kind of boring. Resident sleeper and all that. But the cool thing is I'll be able to get some cool stats soon. Oh, I should have mentioned some of the other things I had to do. I was working on this post stream yesterday, and I got the instrumentation working, but until I got it to work, I ran into these 3 tables, which are trouble. So the G table has all your global variables in Lua. Guess what? That means the G table has the G table in it. So if you're iterating recursively, you'll go into the G table, then you go into the G table, then you go into the G table, etc. So I have it say, if you run into this table, don't recurse into it. Same thing with package loaded. So apparently package is a package. So package loaded, etc. in infinite. So we stop at loaded and we say don't go into there. And in package searchers, I found out you can enumerate, but as soon as you try to instrument the searcher functions, it breaks Lua. So we don't mess with the package searchers. Those are the only things I really had to worry about. After that, I instrument all Lua functions, and I actually have the complete list in the unit tests, because the unit test wouldn't pass until I got all these in here. There's a bunch of stuff with coroutine, UTF-8, table, OS, IO, debug, math, string, and some, miscellaneous top-level ones. And yeah, works fine. If 100% is 22, then what is 1? Easy maths. Why Lua? Why Lua? Because Lua's cool. No, because Lua was super easy to embed. And I am going to make it even easier the more tools I make around it. So we already have a unit tester for Lua. Where are you? Well, that's weird. Why are they listed up here? 1 and 2. Oh, I built it for Visual Studio, and it's finding those now, too. That's neat. Look at that. I can run the ones as it was built with Visual Studio or Visual Studio Code. Cool. You're on mobile, which might be why it took you a few minutes. Oh, to get the mobile notification or whatever. Eh. One's always one. That is true. I don't know what you're seeing the 1 or the 22 on, but okay. Yeah, so I have the unit tests, and now I'm adding instrumentation. So the more I add to Lua, the more feature useful it'll be for me. So I think I'm going to move on to collecting this data. So I wonder if, to keep this unit test intact, I can make start instrumentation have a dependency to say how we instrument stuff. Hey there, Doe. Any recommendations how to learn? Are you talking about React, right? Without knowledge of JavaScript, TypeScript? I think you'll need to learn JavaScript at least. If you need to learn React. Is that what you meant, React? React kind of has JavaScript as a prerequisite. You don't need to learn all JavaScript. You can just learn a little bit to get by. Yeah, just learn the minimum stuff. In fact, what you probably already know from other languages like C++ and Python might be enough. So you know what I'll just tell you what I did. I knew enough of the elementary stuff from just knowing other languages to just go to React JS and just use their built-in get started. So see if you can figure out the practical tutorial, the intro to React. If you can get through this and actually make it work, it just makes a little tic-tac-toe game, I think. Then you're set. I would just start. Like I said, you'd be set for using their tutorial series because it just gets more and more complex from then on. If you can't get through the intro tutorial, then yeah, you might have to go back to some more of the basics of JavaScript first, and then come back to the intro tutorial. I think this is actually a pretty good one. I picked up enough of the basics to get started with it. They're missing some things though, and all I can say is I ended up just learning a lot of things on stream and also trial and error. You just try things out and see if they work, or you Google search them. That's my recommendations. Well, that's weird. It thinks I didn't say hi to A squared. Is my bot? I wonder if something's wrong with Twitch. I'm gonna give A squared another wave. Now it's caught up. Weird. Okay. Hey there, piano boxer. Learning about percentages in math class, and that was on the whiteboard. Long story short, you got a 5+. Oh, on the whiteboard, there are 22 students, so 100% equals 22. So what percentage of our class is one student? Right, that kind of a math question, yeah. I know you got 2 waves because I was testing my stream helper, figuring out why did I have to wave twice? That was weird. All right, going back to this. This test relies on the instrumentation producing those report lines, right? So let me see what the instrumentation is. That's this part, right? Well, really, it's these two. I could put whatever I want here, right? So what if I use dependency injection here? What if I inject 2 functions? So, and we can have them defaulted in some way. That actually might be useful because people might want to instrument things in various ways, right? Yeah, let's do that. Let's have, let's call it instrument before, and it will default to be, I guess, default before instrument, and then instrument after equals default after instrument. And then we need to define what these things are. Isn't it funny how those numbers work when you convert them to decimal? Like, did you know that 0.999999999, etc. to infinity equals 1, but only if you do an infinite number of nines? If you stop at any point, it's not 1. So it's the limit as n approaches infinity of 0 dot and then n nines. The limit of that is 1. One of those weird, funny things about math. I think those things kind of make math fun if you can visualize them. All right, let's make a type. Should I put it here? It's a function of some kind, which means we need functional. I don't think it needs to return anything, so we won't require it to return something, but what it'll be given... I think, Let me think about this. I'm just wondering how to get this self back. New Power Toys has a feature called Fancy Zones to arrange windows on the screen. Could be useful for me. Okay, cool. Thank you for that, Piano Boxer. I'm either going to end up using one of those things like that, or what Playing with Scissors was pointing to me to do, which was auto hotkey. Macros and auto hotkey can be used to arrange windows like using hotkeys, obviously. Thank you. Pretty sure that's called rational and irrational numbers. Yeah, but I kind of think of it as number theory, but I don't know. Hey there, Rally Monkey. How are you doing? Do we finally have more humans than bots in the channel? I'm not sure. Not sure. I need to arrange this. How many bots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many humans? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, it's tied. We have as many bots in the channel as real people. And then there's one person who I don't know if they're a bot or not. They've been watching for 20 hours and haven't said anything. So they could be an extremely good lurker, or they might be a bot. And I don't want to call them out. Why all the bots? I don't know. I think it's just there's a low human count today. Maybe it's just because it's the weekend. People don't want to watch me, and they'd just rather enjoy their weekend, which I understand. That's perfectly cool with me. Oh, why am I confused? Oh, I was trying to decide what needs to go into an instrument. Definitely we need the path. So path is available as a vector, right? So const standard vector. Let's make a type for this using path equals standard vector of strings. And then I can just say a path. And so vector of strings is already included. Aw, thank you, Rally Monkey. You're watching your diet today? That's good. Hope you're feeling better. One problem with that is that you can't split. Oh, wait a minute. No, you said one student, how many percent? If someone asked you how many students is 10%, that might be tough because you can't get exactly 10% out of 22. It's not a whole number. It's 2.2, and how do you get 0.2 of a person? I don't know. Is this alone all I need? Because maybe I don't need to make that an up value. We already have it outside of Lua entirely. That's what I'm starting to think. That we can pass in a function that already is a closure on it. No, wait a minute. Lua only takes functions that are pure. So we're able to use a pure function here, not capture anything, because we have self in the closure as an up value in the closure. So, no, not like that, Manez. Come on. It sounds normal in your head because you're a kid inundated with violent video games. Violent video games have corrupted your brain. I'm... Maybe need to stretch here. Think about this. If we had a generic context value, that would solve the problem, right? What if I did that? So in addition to... Where is it? In addition to these, I have like a context. If we defaulted it... Can I default it to this? Can we do that? May only be used inside a non-static member function. But that is a non-static member function. What? Well, maybe it's not inside, maybe this is outside. So I guess we can default it to the null pointer. And if it's null pointer, then we use this. Do I need the self for anything else? No, I don't. Okay, so that's how I'm going to solve it. We will, this instrument will be given a context, opaque context pointer, like this. And that's what we're going to put into this user data and upvalue it. So that's an instrument. So that means I just need to have the default instruments. And they need to be pure functions to work with Lua, right? How do I define something to be a pure function? Is it enough to just say that? Or do I actually need to make it a C function? I can do that. Hold on. I don't need to tell Lua those functions directly, do I? Oh, right, but they're not... We can't capture them. Shoot. Dang it. I have to make them up values, which means they need to be just pointers to something. Okay, so we're gonna have more up values. Hey there, Crumpet. I'm trying to figure out how to tunnel stuff through Lua closures. How are you doing today? Yeah, I might need to make this not a C++ function, but just a plain old C function. I guess we can do that. So it would just... okay, I don't remember how to do this, so I'll have to look it up. How do you declare... declare C pointer to function? I'm just so bad at this. Okay, there's the example. So it's return type. Then parentheses star. And then I don't need a name, so just end parentheses. And then no bracket at the end. So that would be a pointer to a pure function. So that would be compatible with Lua. Or a void pointer. So that'll work. So then I can just declare these two as pure functions, which you can do by just making statics. So let's do that. I guess we can do it outside here. Yeah, because it's just within the namespace. Okay, so where to do it? like here. Void context and const path. And then there's the default after instrument. I'll document those in a bit. Since these are global, we could have unit tests for them. Just like I have unit tests for do not search, find functions, and all that stuff. Yeah. So these defaults, the way they would work is go back to an impl pointer. Oh, wait a minute. That means I need to declare them inside the impl class, right? Maybe? Actually, impl is a struct. It's not, there's no private members, so I don't need to do that. You could do that actually, Manis. At Qualcomm, instead of saying, okay, Google, or hey, Siri, don't respond, phone. Oh, my phone didn't respond. We would program it to say, what was it? Hello, Snapdragon. It was Hello, Snapdragon, because Snapdragon was the Qualcomm's, the marketing name for our chips. So I know for a fact, like I worked with the guys that did voice recognition, you could train it to say, okay, mayonnaise, or okay, mayonnaise, or however you want to pronounce it, and your phone would respond. You would just have to have the ability to train the voice recognition database to make that the keyword. I don't know if end users can do that or not, but that would be cool. Because then you could have your own custom keyword, right? Right. I think I can get away with... let's see if I can get away with doing this. So if I just say impl, or moon clock impl self equals, well, actually the other way around, const auto self equals typecast to that context. Can I do that? These voice recognition, I do. I use it for whenever I need to set an alarm. It's so super simple now. You just say, hey Siri, set an alarm for, and then you say the time, and it does it. They'll never need to touch the phone. That's the only thing I use Siri for, is to have my phone set alarms. Hey Siri, set an alarm for 12 o'clock. Said, okay, I set an alarm for 12 o'clock. Okay, and I can just turn it off by tapping there. You're not happy with Alexa? Well, this is because Alexa snoops on you and sends your audio to Google. I don't even want to think about where Siri audio goes. Contains private property. Oh, it's inaccessible. Okay, so I can't do that. I can define it inside here. That's what I'm going to do. So that means if it's inside of this class, we can make it a public method, but then they need to be static. Come on, clickers. Static. And then we put in front of here moon clock. Actually, we don't need to do that. I just move them, right? Down into here somewhere. Right before start. There we go. That'll work now, right? It's weird to you to speak alone. It might not be weird for me because I helped the folks working on voice recognition, so I got kind of used to talking to machines. The way I see it, it's just another user interface. They're converting the sound waves that your vocal cords and mouth and, you know, structures in your head are creating sound. It's taking that information from the sound and collecting it back and figuring out, like, what bin it goes into. Was it a command or not? That kind of thing. So to me, it seems natural. And a lot of it's the same way humans communicate anyway. When your ears receive that sound, your brain then is parsing that sound for information, like, did that other human ask me to do something, and that kind of thing. It's the same. To me, it's the same kind of thing. Whether it's a human or a machine, we can talk to them. But kids will be doing and not understanding why you don't do it? Maybe. It's like my kids wondering, like, why do I bother calling them when I could text them? Why are you calling? Can't you just text me? I'm like, yeah, but we called people when I was your age. We didn't text them. All right, I'm gonna try to move the before instrument into here. So that's what this does. That right there. And then we'll replace this with, we need to call the before instrument. Okay, this needs to be updated to have those other arguments. So I'm gonna do that right now. Whoops. Right now. So the default, we'll use the default instruments. We don't need to, we don't want to have these defaulted anymore. There'll be the special case of null pointer, well, I'll just make it this. So we'll say, if context is null pointer, then context equals this. Okay, and then I don't make a self here. I make this a context wrapper. And it's the size of a void pointer. And we store the context there. Okay. That's one thing I need to close on. The other two are the instruments. So I can just make those C functions, right? No, I can't. They gotta be more void pointers, don't they? Because I'm gonna call them. So we're making two more wrappers. So this one is going to be before instrument wrapper. Did I call it before? I guess I did. So I should just say before wrapper. And then an after wrapper. And we just store them. Did I copy it too many times? I guess I did. Okay, so things are on the stack now, right? More things. And more things. 2 and 3. So we're going to close on all three of those. So then that removes them from the stack and replaces it with just a factory. And then inside there we can use the up value. So right now I have just one up value. We actually want all three. So there's the first two up values, which in my notes are path and function, and then the other three will be the before and after instruments, and then the shared context. So that means we'll have two to push two more, right? And then we'll have 5 total up values. Your father just entered the smartphone era? It doesn't work on OK Google. It doesn't? You can't change it to mayonnaise? To mayonnaise? Okay, mayonnaise. But your mayonnaise, your phone isn't. Your phone is Google, right? Uses voice for texting? I think if it's super convenient, even the old people will start to use it. What old people like me don't understand is like why young people don't use other technologies options like voice. Why text? Why can't you just call? You never call anymore. I'm mostly joking. Okay, so I don't need this self anymore. Instead, we're going to pull out the before and after wrappers, so, and the context. So I need to get these all correct, right? So they're both instruments, and the other one's just a void. I guess, yeah, I guess I should have the type here, correct? There we go. Why is this not work? Oh, that's already a pointer, so I don't need a double pointer. Yeah, that's already a pointer type. So single pointer. Okay, now what are the up value indices? I think this would be 3, 4, 5. So I got this backwards. Context is first. Should I just keep it in the same order? Yeah, let's keep it in the same order. So before, after, and then context. Before, after, context. Before, after, context. We can do this in the correct order. It's always path and then function. So that's the function index, right? Well, no, let's just leave it. 3, 4, 5, I just have to remember that's the path, that's the function. Okay, so that's before, after, context. And so then we're going to get the path and we're going to call before, context, path. And then we're going to do the thing. But before we return, I want to const auto num return values equals, and then we're going to return the num return values. But before we do that, actually, I guess the instrumentation could modify it, so we can just leave that the way it is. Maybe we should give the instrumentation the Lua interpreter too. That might be convenient. That would be super convenient. So let's do that. We'll have a Lua context and path, and then this one will have an after Lua context path. And then I just need to modify instrument to take a Lua state. Where's the phone app on my phone? I'm not a boomer, I'm Gen X. Boomer would be, what? In their 60s? No, I'm in my 40s. I'm not that old. I don't know how to say your name. Wrecked you easy? You wrecked me easy? Nice. Hi. How are you doing? Oh, did I never wave to Doe? No! I didn't wave to you. Or if I did, my stream helper didn't notice it. Hey there, Doe. Okay. He took it as a compliment because he's 88. Oh, he's older than a boomer? I didn't know he was that old. I would have thought that he was a boomer also. But then again, he was in black and white westerns, right? William Shatner, when he was really young. So if he was an actor when it was black and white TV, that makes him pretty dang old. What do I think about Java? It's okay. I put it on the same level as something like, I don't know, something like C++, something I've used for years and years. It's got issues. It's kind of old, but it's still pretty good. I don't know. Don't have anything against it. Okay, I'm trying to figure out now how to... Basically, I'm putting in these dependencies so that the instrumentation can be shared. Ooh, did I screw that up? I did. I messed that up. And that should be void star. And that should be void double star. Okay. Why does it have a problem with the closure? That should not be a problem. Let me compile this and verify it's not a problem. It is a problem. Why? Oh, the default, it's something else. It's my default arguments aren't right. So the default arguments have to be extended. I mean, the default instruments have to be extended. They need to be given a Lua state. So let's do that. There and there, done. Making a game with Java and GDK-lib for Android. Cool. I don't know why people would say it's bad for 2D, 3D games. I think it's just fine. I think Rally Monkey was looking into either like doing Android stuff. He might be able to give you some insight, Java versus Kotlin versus native stuff. The tinkering I did in Android was mostly user interface stuff, and so Java was just fine. I did some native programming on Android. It was a pain in the butt at the time to get working, but it worked just fine. Like we did OpenGL stuff or OpenGLES stuff for Android, and that's all native code. And then they added Java support for it too, which was nice. I mean, I don't know enough, I think. You'd have to ask someone like Rally Monkey who might have looked more into this. I would guess it's still just fine, even if Google is pushing Kotlin now instead of Java. Okay, where is the error now? It says it can't take my Lambda as is, so my Lambda is, something's wrong with my Lambda on line 221. My closure is not good. Why not? Oh, because this doesn't return something. I messed that one up. There we go. Okay, did it get further? It got further. Oh, my start instrumentation isn't up to date. Oh, no, it is. It's that when we call it. Way down here. Yeah, so, what? Oh, the outer and the inner need to match. Yeah, okay, so yeah, let's just make them match. Comma. Or get rid of the defaults. And we just pass them through. Before, after, context. It cannot link because I'm missing something. What am I missing? Hold on, what? What does it say it's missing? Default, oh, wait a minute. Oh, because those are inside the class now. Shoot. Default begin before instrument, right? They're not in impl actually. They are outside. Where did I put them? They go after start. No, before start. The outer start, yeah. I put them in the wrong place. So they go here. Moon clock goes there and there. Fixed. All right, so let's make sure I didn't break anything. It's mostly the big refactoring I just did. Moon clock is not found. Search for it, please. Moon clock. Green. Green is good. Okay, so I made the instrumentation use dependency injection, so then I can make the dependency explicit here. I can just remove, I can just take those instruments and take them out and hard code them into the test like I want. So if these lines, for example, let's just pull this report, let's just pull the lines out, right? And say, let's set them up here. I don't know where am I gonna put them? Right here, I guess. So there's some lines. Okay, and then we'll need an instrument that sets up those lines. So here's my before, let's say const auto before instrument, or just before. And so it's a pure function that takes that. The path is a moon clock path. And we're going to I'm just going to make the context the address of these lines. So const auto lines is star and then pointer to that context. And then we'll just say lines. I need to make that a reference. Did I get the type right? Yeah. Oh, not const. There we go. And the after instrument, we can just have it do nothing. After instrument, do nothing. Need semicolons. Okay, and so then we can just say before, after, and address aligns. Done. And it should still work. And now I've separated the dependencies from this instrumentation, so I can change the default instrumentation to do something else if I want. Oh, I broke it. Oh, because it's looking at the wrong thing. It's looking at generate report. So we don't care about generate report anymore. We're just going to look at our own lines. So I'm going to remove those lines from the generator report in a second. There we go. So it's completely separated. Not considered good practice to pass shared pointer by value since you'll be unnecessarily increasing. Yeah, I made that mistake before, iGrok. I'm supposed to pass it by const reference, aren't I? But I do actually want to keep the reference inside here. So let me fix that. I'm going to store a reference, but I don't need to unnecessarily add one, so I can just do that, right? It can be const shared pointer, right? Because I'm not modifying the original one, I'm just making another one that shares the same one. Well, it is in production. That's the external. That's the main API does that. So yeah, I think I should probably do that. So it doesn't increment the reference count and decrement it unnecessarily. The only time it should increment the reference count is right here, where it makes a copy. Yeah. So let's fix that. That's an old bad habit that I have. One more place, right down here. There we go. Fixed it. We're not transferring ownership. We're actually adding a reference. Because the intent is that, yeah, the intent is that the, why did that show and then disappear off the now showing? Did that not work? Let me do that again myself. That was sort of confusing. Yeah, so that thing you're seeing there is featured chat, by the way, and then so I was addressing that. Really, we should feature this one. What iGrok said before. So yeah, before we were doing that, and what that does is, because it's passed by value, the compiler will end up constructing this, which adds a reference count, and then destructing it on return, which is then decrementing the reference count, even though we didn't actually need it. So it might as well be it might as well be a const reference, and that means we're borrowing a shared pointer. Now, why is it a shared pointer in the first place? Is that the moon clock is going to share that Lua state with the main program. So in the case of my tests, the test framework actually owns it. It's ultimately held where? Right here, right? And we do a new state, so we take care of the lifetime ourselves. And that's what the main program chooses to do. Another program could choose to actually use a shared pointer, but either way, I said in the interface here, I chose to do shared pointer because I want to make a statement in the interface level. I want to say, hey, not only do we want to make use of your Lua interpreter, we want to have shared access to it so that we might retain a reference to it. And I don't need that yet. In fact, I might not need it, in which case I'll remove the shared pointer. But in case I do, that lets us save a reference, which is what I do. That right there. So we keep our own reference to the same Lua interpreter, and then oh, you know what I forgot to do? I forgot to release the reference down here. We should do that too, right? I should say Lua dot reset to get rid of it. Oh, that was your fault? No problem. So yeah, but the unnecessary reference add remove happens if you pass them by value. So I guess I could make it where I move it in, but it just makes the syntax look kind of gross. I'd rather just say, hey, we're going to take your shared pointer and tell this guy about it, and he's going to take your shared pointer and make a copy of it. So that's where the add ref should happen. An add ref and then storing the pointer, obviously. I could have done it the other way where this one is a copy. So like I could do it this way, right? I could say, we're going to make a copy, and then I can just move it in here. But then I'd have to go to this other guy and say that that is an R value. And then I'd have to say that is moved there. So I just as well not say move in two places and use R value semantics because it's harder for people to read. I'd rather just say, hey, don't even make another reference. Just use an existing reference until we get to here, and then we're explicitly saying, oh, we're going to make another copy of that reference. See how that goes? Little tricks with reference counting and L versus R value references. Okay. And I'm by no means an expert. If I misspeak, then I'm sure iGrok will let me know. iGrok knows a lot more about C++ than I do, I think. I'm still trying to catch up to modern C++. I was on C++ 98 for like so long. It all sounded right to you? Makes me feel good that it sounded right to you. Well, I do one kind of trick, which is, I talked about this yesterday. This is how you, what do you call it? This is how you make a shared pointer not really share something. It's basically saying don't do anything in the deleter for the shared pointer. And the only reason I can get away with this is that shared Lua, I'm giving it to Moonclock, and then I'm explicitly saying stop here. And Moonclock is declared up here. So that means it'll be destroyed when the test returns. And Lua doesn't get destroyed because it's actually a member variable. Hold on, I shouldn't have just scrolled. Lua is a member variable, right? So technically Lua lives longer than Moonclock. So if I give Moonclock the Lua pointer, that's okay, even if it's not really shared, because Moonclock's going to be destroyed anyway. Now, if Moonclock did something weird like talk to some other subsystem in my program and passed it the shared pointer thinking it's really being shared, the problem would be once this test is destroyed and that Lua ceases to exist right here when it's torn down, if Moonclock did something funny before it got destroyed, like it passed the reference on to someone else, then that someone else wouldn't be able to use that Lua reliably. Why even make it a shared pointer if you're using it like that? Because I wanted it to be in the interface to be explicitly shared. The test just doesn't make it shared. I guess I could make it totally clean by making it a shared pointer. Because this might be confusing to have that. Okay, so yeah, let's improve it a bit. So given that the interface is explicitly saying I want to share this Lua with you, to make it match here, I ought to make it a shared pointer, right? Something like this. And then I don't need to assign that to null, and then what I can do here is I can say that this is a shared pointer to a Lua state. Construct it like that, and then destruct it like this. Lua close Lua. See how that works? Then I don't need to do that. I can just say Lua.reset, and then it gets... The side effect is all these Luas now I have to do a .get, because we're converting to a C API. So that is the one downfall of that. That stays Lua, but these have to be .gets. So I'd have to live with that part of it. All these Luas have to have a .get on them. And actually, I can just do this. Okay. Oh, wait a minute. No, I can't. I can if I click whole word. There we go. Fixed it. Dot get. And more. So maybe the cost is too high. That I have to say dot get for all those. Quite a few places. Getting more expensive. I don't know. Make sure that this actually works, and then I might undo it because there sure are a lot of dot gets that I'm doing. And then I don't need to do that. I need a get there. I think there are a couple places I screwed up too. And then instead of shared Lua, it's just Lua. And then there, a lot of places actually. But this should work also. Unless I screwed it up, and I did. 219. Oh, that took a raw pointer. Yeah, so it works. So I don't need to worry about the close. If we wanted to make sure it got called, I can go to where I called it, to where I close it. Turn that off. And I can make it so I can put a breakpoint there and we can see it. So build it. And then debug it. It gets called part of the teardown sequence of the test. Right, part of the teardown is to reset that, and I think even if I don't reset it, it'll get destroyed naturally. So like I could just not bother doing that, and it'll still work. So the advantage of making a shared pointer to begin with is you can put the create and the destroy in the same place and not have to have the teardown worry about it. But then the side effect is if you're going to use it with the C API, you have to unpack the pointer from the shared pointer. I mean, I guess it could be optimized. Let's see what iGrok wrote. If you're not using the deleter, you may as well just be using a raw pointer. Yeah. It's this interface though. We don't make any claim about how it's created or destroyed. We just say, hey, we need to borrow your Lua state. We want to share it with you. We're not in charge of creating it or destroying it, so make no assumptions. Hey there, Romania hate. Make a share point with the deleter that calls Lua cleanup. Yeah, I like that trick. It might be cleaner just to make it temporary. Then I have to have another name, right? Like raw Lua or something. So I might undo all that because this is a test framework and I don't really care about it being super clean. So I'll just if I undo, I lose the putting the create and the destroy in the same place, right? Because it's now a raw pointer again. Since it's a raw pointer now, the tear down has to do the close. And technically, we should also do this. Although I'm kind of on the fence about, some people are adamant that to get full symmetry, teardown should put it back to the state it was in before setup was called, and Lua close doesn't do that. We had to explicitly set it to null pointer because it was null pointer to begin with. I'm like, I'm okay with that, but then again, we know it's not going to be used after teardown, so why the heck are we bothering, right? Code cleanliness. Yes, since this is a test framework, the little bit of ugliness by having to manage the lifetime, create here, destroy the here in a different spot, and then otherwise just handle it as a regular pointer, and then have to have that adapter right here, which is basically making a statement that says it's okay to share it as a raw pointer. And then someone would ask why, and then I'd have to explain, well, that's because the thing that we're sharing it with, its lifetime is less than the Lua interpreter anyway, in this test context. So it's okay. But this still might be considered a code smell. It's like, ooh, what happens if they take that shared pointer and hold on to it? It's like, well, yeah, the deleter didn't do anything, so yeah, it could be a problem. Hey there, Raz. Oh, let me get some waves out of the way. I forgot to wave to iGrok. And M Drake, I didn't see your chat at all. Minecraft was written in Java, so it's clearly possible, maybe not optimal. Yeah, lots of cool things are written in Java. It's not my favorite language, but I don't have anything against it. Especially on Android, where the framework has a lot of support for Java. An iterator next. How are you doing? Okay. I think I want to move on. So I have now the instrumentation, the actual instrumentation that we're doing, dependency injected so that the test framework can do a silly little thing, which is down here, which just takes the path and joins the path segments with dots and then puts it in a vector and then just checks that vector at the end. And then we can now change the default instrumentation to actually do some timing and other cool things and not have to change this unit test. So I think that's what I want to do. Actually, you know what I'm going to do? I'm going to have the default instrument itself unit tested. That's what I think I want to do. Let's make a test for that. So right here. Default begin instrument. So we're going to end up calling that, because it's a free function, right? Moon clock moon clock again, because it's inside the class. Default before instrument, and we're going to be giving it a Lua interpreter. Yeah, and then the context, it needs to be the impl of something. So actually, can I get away with this? Actually, I don't know if I can, because this guy actually expects it to be an implementation pointer. And we don't have access to that from the test, do we? So maybe I technically can't test it, so maybe I should just mark it as private. Actually, can I mark it as private? I don't think I can. Let's try. If I mark these as private, is it gonna... What's it gonna do? Private methods. Is it gonna throw a fit? No, it actually works. Interesting. I think that's how I want to do it, because they have access to impl, and so I can't even test them. Unless I can mock the impl. No, I can't even mock the impl. Yeah, so I can't even test it. So let's just do it that way. Default before. How come I'm not finding it? I'm in the wrong file. Okay, I want to put them in the same order in which they're listed in the header. So after generate report, put it there. Okay, so I can't test them directly, but I can still make tests that test them. I want to be able to test them though, because I need to be able to mock, when I start doing timing stuff, I need to be able to mock the timer. Hey there, Adrian. How are you doing? And, oh, we already said hi to... I was going to wave to someone else, but I'm like, oh, they're already here. I'm looking into how to instrument Lua stuff, and I'm looking at... the default instruments right now are using the implementation side of my class, so it's difficult for me to test them. I guess I could just use more dependency injection. So I'm thinking, like, when Moonclock is actually going to try to measure time, we could have a dependency that specifies how time is measured, and then in the test framework we can totally mock that. And then keep this the way it is. This is just testing custom instrumentation right here. Should we test the after then? Yeah, let's say that this is a more complex thing. So standard string before plus that, and let's say make this one do an after. And then change this to should be oops, before, after, and then 2 more times, right? Still passes. Cool. Actually, if this is testing the instrumentation, then the only thing really left to test is when I change the so I really need to make this testable. I know what I can do. I can have like a get default context out of this thing, and it's still opaque, and you can only use it to pass it back into that. And then I can make, yeah, so I can have this go back to being like that. Yeah, this is how I'm going to do it. To get the context, which is the impl, we'll just have another method called get default context. Void get default context. I'll do this until someone tells me it's horribly wrong, and then I'll reconsider. I think this is okay, though. This is mostly just to make it easy to test. In the real world, I expect that you'll just use the defaults. Actually, maybe I should be explicit here. Yeah, I should. Or can you do that? Maybe you can't do that. It's telling me I can't, but I think I can. I'm not sure, though. I'm going to move these back up to right there. So this should say return this. Or return impl get. So it's an opaque void pointer. The reason why it might not be bad is it's exposing the impl, but it's really only to be used in that way. Okay, say I can't do that. Call of non-static member function. So you can't call a non-static member function in the default. Okay, we'll just use null then. And then change this to be, where is it? This one here. Well, hold on. It should do the null check here. If context is null, context is get default context. And then this doesn't need to do that. That way it's all in one spot. But I want the default context so I can make these two testable. So yeah, let's go back to making tests for them. Okay. Default begin instrument. Before instrument, sorry. Begin, before, same thing, right? Okay, so we're going to end up calling it with Lua, a context of some kind. Oh yeah, that's right. It's moon clock. Moon clock default before instrument. Lua. So here's where I need to get the context. So we need to actually make one. Make one, please. And then hold on. Am I going to run into trouble because You have to call start instrumentation to get the Lua interpreter assigned. You know, that's okay. I can call instrumentation just for its side effects, right? Because the other function tests that. So we can do that. So we can just say, we can just call it for its side effects. The moon clock, start instrumentation, Lua, and just the defaults, right? And then we're going to, oh, why did it not like that? Oh, yeah, why didn't it like that? Oh, it wants a shared pointer. Yeah, forgot. There you go. Share it, please. It's all yours. And then, right, Lua, right, the context, and then the path. So the context is moonclock.getDefaultContext. That's sort of a requirement to use the default instrument. And then the path, here's where I get to play with it, right? So right now, if we put in stuff for the path like foo bar, and let's call like call it again with like actually let's do foo and then do bar. Right now the expectation is that when we call moonclock.generate report, it's going to give us a report, right? And the report is going to have lines in it, and those lines should have those strings in it. So expect equal vector of strings. Actually, did I have a type diff for that? Well, that's a different vector of strings. I don't want to use path. This is a different one. Report. Yeah, it's just explicit. So this should be like just foo and bar for report dot lines. So now I can test these separately, and then when I change the default instrument's behavior, I can it'll only affect this test, and not this function. So this function is done. The instrumentation is tested. We're just now concerned with what the instruments do. So the default after, and actually, if these are paired, maybe I should test them together. Default instruments, because they're intended to be called one after the other. So we're calling foo, and then while calling foo calls bar, right? So then the naturally it would roll out. You do the after on both of them, right? After bar and then after foo. So now we're testing them together. Cool. All right, I like that. So given that that's what the expected current behavior of the default instruments is, now we can change it to where like we can like measure time, right? So to do that, we need to introduce some other dependency to represent time. And in the past, I just made something called a timekeeper. I wonder if I should... Did I abstract that away? I think I might have. Did I put it under something called timekeeping? I did. Is that what I want? It records it as double. Timekeeping clock. What uses timekeeping clock, actually? Timekeeping clock. Oh, this is used. Oh, right. I was planning to obsolete the old interface and use this general purpose one. So that's what I should start to do, right? Yeah. Okay. Cool. How does Java treat strings? What is it you don't like about how they treat strings? I don't remember. What was it about it? Oh, you're used to them being primitives? I'm used to them in most languages not being exactly primitive, but pseudo-primitive. Like in Lua, they're primitive, but yet they they're really composite primitives. They have even smaller primitives inside them, right? Individual characters, and then there's a length. Yeah. So they're treated like a full-blown like composite object rather than so they lose some of the advantages of primitives then by not being treated as such. Okay, I think I'm going to want to require this. So that means moon clock will depend on timekeeping. And so will its unit tests. So update the build system. And let's go ahead and define one. So we'll include timekeeping. And why is this not working? Am I having a build problem already? Is that not how I spelled it? Oh, I did. It isn't how I spelled it. It's lowercase. Interesting. Good to find it now, rather than accidentally have it the wrong case, huh? What kind of society lets their children grow up using Java? I know! Man. Okay, let's make a timekeeping clock. So, where to put it? Right here. So, class, or just a struct, I guess, mock clock is a timekeeping clock that overrides. I need to go find that. This one. Very simple. Get current time. Override. Return time. And then we'll have public properties. Public. Actually, I wonder why I'm even doing this. This should just be properties. And methods. And then the property here is just the current time. All right, so that's the mock clock. The idea is that we'll give moon clock this clock, and it will just be a mock clock so that the test will drive what the current time is, and then we can get expected results. So let's play with that. So let's update the default instruments, and let's have moon clock. Hey, I'm being raided. I still don't know how to say your name quite right. Let me give it a shot. Jay Langsdorff. Hi. Thank you for the raid. Anti-pixelated. How are you doing? Hey. I'm just about to start making the instrumentation for this framework I'm doing for making Lua scripts automatically studied for performance analysis. I'm doing good. Thank you for asking. So yeah, I started this yesterday. The idea is to make a library that is a companion to Lua that you can call something like instrument all my Lua code, and it finds all your Lua functions and does essentially this to it. It'll take your function foo, let's say, and then run it, make a wrapper around it and assign it back to foo, so that when you call foo, it'll start timing, call the original foo, and then stop timing, and at the end you can generate a report and see how many times was foo called and how long did it take. That's the whole goal of this. So yesterday I did a lot of groundwork to make the library, have it enumerate all the functions in Lua, and today I got it to where we hold on to the instrumented functions in the Lua registry, and we use that function registration later to unwrap all the Lua functions when we stop instrumenting. And now I'm moving on to where we want to collect data for every instrumented function. And whoops, I did not mean to flip over to that. The interface looks like this, where you'll just say start instrumentation and stop, and there's a default instrument. So when I use the word instrument, it means something to run before and after everything you do, every function call. So for example, your instruments might start a stopwatch at before and then stop it and after, and then take the difference between the two times and write down, okay, function foo took 3 milliseconds, right? And it might increment a counter saying we called foo another time. So that's what an instrument is. So there will be default instruments that are provided by the implementation, but you can also use dependency injection here by replacing the default instruments with something else. So the test framework I have for this does this, so it makes some silly little instruments where it just takes the path of the function and puts it into a list of lines, so that at the end of the test we can say, well, here the before and after instruments for foo were called 3 times because we called them 3 times, right? So this effectively tests the instrumentation part, and then what the instruments do themselves we're going to test here, at least the default ones. We're also allowing the user to provide their own instruments if they want. So the default instruments right now will just print out the names of the functions. So we're going to change that in a moment to instead, I think I wanted to just record the start time and the end time and the difference and put that into the report line. So first we needed to have the concept of timekeeping, and I already have that in this clock interface. This is just a very, very simple generic interface. It's pure virtual, saying a timekeeping clock is something that if you call it to get current time, it gives you a time in seconds. I guess this says it's Unix time epoch, but it doesn't have to be for the purposes of metrics collection. And then in the test framework, we're going to provide a mock. The mock looks like this. So instead of actually measuring a real clock, we're just going to return some variable. And the test framework is going to change the variable as the simulated time advances so that we can make sure the instrument behaves correctly. So how this all fits into what I normally do on the stream, let me give you a brief intro to that. So I'm working on a game. The game is playable now, but there's not much content here. Here's probably the biggest part of the content. It's all test content right now. The game is multiplayer, and the backend server is in a custom game engine that I'm writing in C++, which includes a Lua interpreter. And the Lua interpreter is used to run all the game logic, like controlling these NPCs and how they move and act, you know, when they fight each other, when they drop loot, that kind of thing. And the front end of the game, it's played in your web browser. The app connects to the back end of the game through WebSockets over TLS. So the engine is evolving to the point where I'm doing more and more stuff in Lua in the game logic, and I want to have tools to support its development. So a couple things I'm working on. One thing I finished, and the other thing I'm working on right now. The thing I finished is I use in VS Code a couple extensions for doing test-driven development. So I use this Test Explorer UI, which they don't have a whole lot of screenshots, but along with Test Explorer UI, if you use the Google Test Explorer, and this one doesn't have good screenshots either. What the heck? Oh, here we go. It adds a panel which shows like which tests of yours pass and fail. So that works for Google Test, which is a C++ test runner. And I use that quite frequently for all of the stuff I work on. So one thing I did for Lua is I made a special kind of test runner. I called it Moon Unit because Lua is Portuguese for moon, and we're doing unit testing. And Moon Unit is the name of Frank Zappa's daughter. So I thought it was a cool name. So I made something called Moon Unit. It looks like Google Test as far as this extension is concerned. It says, oh, look, there's just another Google Test runner. Let me run it and figure out what the tests are. But when it actually runs, it's not running C++ code. It's actually running a Lua interpreter and running a Lua script. So that's one tool I made. So now when I work on my game scripts, I can do it with test-driven development. So I have little unit tests for everything. So here's the combat system, right? We simulate different scenarios and make sure that things happen correctly, like things get attacked or they don't. And so that's cool. We got unit tests. And so the next thing was, well, what if it's running too slow? There's nothing built into Lua, nothing that I knew about to actually measure how fast functions are in Lua and how many times you're calling a Lua function. So I decided, well, Lua is very, very flexible. Let's just make something else that does that. And I'm calling that Moon Clock. So Moon Clock is a library that is made to be a companion to Lua, where you can just say, you can load all your Lua scripts, and then you can tell the Moon Clock, hey, start instrumenting. And it'll go to your Lua interpreter, find out where all your functions are based off of the global variable table. So as long as it's reachable anywhere through the global table, it'll find it. And it puts a little wrapper around every function. And you can either do whatever you want before and after the function, or you can use the default instruments, which I was talking about a little bit ago. The default instruments are going to do the typical things like start a stopwatch, end the stopwatch, take the difference in time, write that down somewhere, count the number of times every function is called, and at the end, you can say, oh, give me a report, and the report will give you data based off of what the default instruments are. And if you override the instruments to do your own thing, then you'll probably be doing your own report, and so you won't call that. But yeah, this takes away the burden of having to figure out where all your functions are and add wrappers for all of them. You just provide the instruments if you want, or you use the default ones, and you get a nice report at the end. So that's what we're working towards. I will be using this to figure out why certain things in my game are very slow, and then work to optimize. The optimization could just be figure out if I'm calling a function 100 times and 99 times it's doing the same side effect and the same return value, we could cache it, right? It also could be things are slow because I just didn't write it very well, and I'll take the what do you call the worst paths, the slowest parts, and just work on them. So that's what I'm doing and why. If you have any questions, please let me know. I was an Ultima 4 fan, yeah. So you can tell this is inspired by the old Ultima games. It's in my notebook. I talk about it. It's one of my life goals has always been, since I was a kid, to make my own game like Ultima 4, Ultima 5, and that's what I'm doing. So it's a bit of nostalgia. It's not going to be a game like today's games. It's going to be more retro because that's just what I wanted to do, what I've always been doing. And it also makes the graphics a little bit easier to do, right? Since it's retro, it doesn't need to be very advanced. It can be simple tiles with simple animations. And I can just say this is a retro game and not have to worry about hiring like an artist and a designer and an animator and all that stuff. So that's my spiel. One of these days I'm going to record that as an intro video and just say, here's a link, watch this 30-second video. Now you'll be up to speed with what I'm doing. Okay. I was going to put this clock in, right? I'm wondering if I should take this stuff out and make it so that you set the instrument separately. Actually, no, I'm not going to do that. But I am going to make the timer. Actually, maybe I do the same thing with the timer. Just have all the dependencies in the start instrumentation call. Actually, I'd rather not do that. I'd rather keep it separate. Let's just make it separate. So we'll say set clock. And we'll have it take a timekeeping clock object. And we're going to share it, right? So it's going to be a shared pointer. And we're not going to want to steal theirs by value. Actually, maybe we are. We'll do a move assignment. This will be fun. We're going to make a copy of a clock. And how would I test that alone? I guess I could test it knowing how the default instruments work. We'll think about that in a minute. Let me just make a let's make the framework for a test. I'll just have it do expect truth from falsehood so that it always fails to remind myself that this is to do. And this will be a set clock. We'll have a test for set clock later. Low poly 3D is much easier than pixel art. That is one option, like Factorio does that, right? They do low poly 3D. So they just do all the 3D models and then they render it as low poly. So it looks like pixel art, but it's not really. I might end up doing that in the future. I just don't know how to do. I don't have the prerequisite knowledge to do it myself yet. Okay, still looking at this, right? So the default instruments need a clock. So we're going to, before we start instrumentation, we're going to set the clock. Set clock, and we're going to make a clock here, I guess. So mock clock. Set the clock. We should properly make that. Let's do const auto mock clock is a make. Hold on, I can't type. Make shared mock clock. Then I can just set it there. Start instrumentation. So we can start toying with the times here. Mock clock time equals 1. And then advance it to 1.2. And then when it ends 1.3, and then when this ends 1.6 or something, right? And then we can say, well, now we want to see not just the names, but how long the function took, right? So let's have it just print out the total time. Thank you for the follow, by the way. So the total time for foo ought to be that minus that, right? So that should be 0.6. And then bar should have been that minus that, which is 0.3. So make it compile. It doesn't compile because false is not a variable. That should just be false. What's it telling me now? Timekeeping is not a class or namespace. Well, it should be. Include timekeeping clock. There we go. Should bar be 0.1? Probably. I wasn't paying too close attention. Oh yeah, you're right. It's 0.1. Thank you, Toulouse. I've successfully lured Toulouse into procrastinating more. by planting... No, I'm just kidding. I'm gonna say planting bugs for him to find. Alright, so we need to give a body to set clock, right? And we'll just have it do nothing. Test-driven development is you try to see what you can get away with. We won't be able to get away with this very much. Oh, it didn't link before, so I need to refresh to find it again. You swear that happens? Yeah, maybe. Okay, run the tests. It's gonna fail, right? Set clock we know fails because we haven't written that yet, this one. So it's not printing out the times because we haven't changed the code to do that. So here's where we get to implement the code. We're gonna say, move the clock into place. That's why I made it pass by value, so that that can just be one of these. Okay. Find the reference, please. Oh, come on. Come on, IntelliSense, you can do it. I guess I'll find it myself. Sad face. Here we go. Clock. Need to document those. Okay, so that's how we set the clock, and then we're going to use the clock in the default instrument. So the idea would be to record what the time was when this path was entered. So conceivably, I would do self, I don't know, times reference path equals self clock get current time, right? And then the after instrument would, let's imagine that this has two things in it. Start, and then we'll have a const auto finish, and I entered recover the self from the context, of course. And then we can say, we can store back into here total equals finish minus start, right? And so I just need to make times a thing, so let's do that. I have it in mind to make that an unordered... Oh, wait a minute, we had this problem yesterday. We can't use unordered map because it doesn't like vectors of strings to be keys. So if I had to make it a map, right? Path to function information. Time, actually let's rename times to be, hold on. Can I just search for it in this one file? Oh, okay, so it's safe to replace all. Let's make that function info. Have I used MoonScript before? I've seen Leaf use MoonScript. He was streaming a few times. So yeah, MoonScript is designed and used by the creator of itch.io, and I watched him use it. I don't need anything that sophisticated in my Lua. It's pretty simple. So I haven't looked into MoonScript. I'm okay with just vanilla Lua myself. Unless you tell me if MoonScript does unit testing or performance measurements, then I might look into it. Although I'm having kind of a fun time doing it myself. Map. The compiler might actually not warn about using equals instead of minus since it's valid syntax. Do I have a problem? Uh-oh, we found a bug. Found a bug in maybe one of my usings. Okay, I don't see it. Well, don't tell me. Let's see if I can figure it out. Okay, this should be a type, right? And this is all internal, so I can just have types here. Struct that. And we want start and total, right? Let's see if the compiler tells me what it is. Okay, cannot assign to a variable that is const. On line 319. Because I made it const, I guess. Hold on. Oh, no. Minus. It did catch it. There you go. Saved by const correctness. There you go. So if I had made that not a const, it would have been valid syntax. Yep. See? That's why I always use const whenever I can, because it catches that stuff. It catches all the funny things I do. That, kids, is why you should always make things const unless you really are going to change them. Okay, and then this is still not going to pass because the report doesn't actually print it out, right? So we need to make the report printed. Okay. That we were doing in this before, so let's move this to the after instrument and say, actually, I guess I didn't need the total in there. I don't need the total. Let's just remove it for now, and we'll just make that a const auto total. And so this is going to push back more than just a join. We're going to do a full-on printing something out. Actually, we can put that in front and just add that. And then I think I just need to do a .lf, right? With total. Nope. I need a colon and a space, and that needs to be a G, I think. Getting there, but they're in the opposite order. Why did I have it the other way? Oh, I don't remember why. That's sort of maybe a ridiculous requirement. Maybe we change lines now. Be more convenient if it was a map, right? Because this function info is already a map. What if the report just was also a map of paths to yeah, why don't we just put that directly into the report? Currently checking out Elm. I remember Elm as being an old school Unix email client. What is Elm now used for? How other languages work? Cool. Hey, Master Agent Miyazaki hosted for one viewer. Thank you for the host, my friend. All right, we're getting somewhere. Should I just put this directly into the report? That might be a useful thing to do. It's just that I need to declare it up here where I do report now. Select that, right? And that means that path, that function information needs to also be public. So just moving it around, that's no big deal, right? Here's the function information. We are including, no, we're not including maps, so let's do that. Okay, do I need map here? No. Okay, so this should just go straight into report dot function info. Right, and then we would just... Okay, I guess I'm going back to putting the total in there then. That's fine. So there's a little trick I can do here. We're looking it up twice, so I can just look it up once. So I can say auto function info equals that. And then just replace... Why is it going backwards? Control D... Why is it going backwards? That's weird. Huh. Okay. I didn't expect Control D to select up instead of down. That doesn't exist yet. Start does, so I need to add total. And then I don't need to do this anymore. I just need to change what we expect in the test. So the test should now expect this there. And these types are moonclock types. And the key, so everything will be a key value. The key will be foo. And the value will be a structure that has 0.0, no, it'll be the start time, right? 1.0, and the total time would be 0.6. A lot of chat just happened. Don't understand any of this. What are you creating? I'm making a game, and in my game, I use the Lua scripting language to control how NPCs move and fight and drop loot and stuff like that. And I have a lot of scripts, and I want to kind of see how much time every script takes to run. And so I'm making a program or a library called Moonclock that you attach to your Lua interpreter, and it's going to measure how long every function takes. So you can imagine that if there are two things called the before instrument and the after instrument, and they're called before and after every Lua function, this is simulating that, like, if the time is at 1 second, and then we enter the foo function, and then 0.2 seconds later, we call the bar function. 0.1 seconds later, it leaves the bar function, and then 0.3 seconds later, it leaves foo. That we want to get a report out saying foo started at 1 second and took 0.6 seconds, and the bar function started at 1.2 and took 0.1 seconds. And these instruments, along with the instrumentation, you'd use in the live game that I have, you get a whole list of all the functions that the game runs, and how long they all took to run. And then I'm going to add more and more information here as I need it to kind of try to pinpoint where the places I need to optimize in my game scripts. So that's a really high level quick run through of what I'm doing. So if you have any specific questions, let me know. You had some hangups? I should check out your stream, Master Agent. I didn't know you were a streamer. I've seen you in chat in other streams, but I didn't know you were a streamer. Oh, cool. Let's see if I can say your name correctly. Gorotkar? Gorotkar? That's hard to say. I'm probably not saying it. Oh, it could also be Go Rewrote Core. That's the trouble with these names that are all in lowercase. I don't know where the words. The first one was good. I don't even know how I said it the first time. Gorotkor. Sorry, I'm butchering the name, but hey. And yeah, thank you for the host again, Master Agent Miyazaki. Hello. Okay, so that's what we expect. I don't know if I can do that without a constructor for this guy, though. I thought I could get away with the fact that it's just a plain structure, but I don't know if it's going to let me do that. Thank you for those follows, by the way. Oh, I know why, because it's not relines, is it? It is function info. Oh, the squiggly didn't go away. I'm going to probably need to have a constructor of some kind. Let's see what the compiler tells me. Too many arguments for a function like... Oh, function like macro. I've seen that before. That... If I move these parentheses out, sometimes it fixes that. Nope, that didn't work. Function info or function information is not a valid template type argument. Ooh, it got really confused. I wonder if I need to put more parentheses. More parentheses! Nope. It's not a member of Moonclock, it's telling me. I thought it was. Oh, it's not just a namespace, it's also in the class. I wonder if I should just move that out then. That would be convenient. So let's do that. I'm probably going to rename this class anyway to be like instrumentation context or something, or instrumenter. These type definitions probably ought to be moved next to path, way up at the top here. That kind of makes more sense to me. So we'll do that. And then I don't need types here. Let's see what I need to fix. Okay, I broke a bunch of things. I'm looking to see what line it's on. It's really confused. What's the line number? 544. So right here. It really doesn't want me to construct stuff like that. What if I just... Let me make sure that this is otherwise going to build. Okay, so it's all in making the expectation here, so something's not right. The type of that is, right, map from path to function information. The type of this is map from path to function information. Path itself is a vector of strings. That is a vector of strings. Is it just this that it can't do? So I might have to make an initializer list constructor for function information. I didn't think I needed to, but okay. Let's just try it. Let's do it. So there's function information takes standard initializer. I forget how to do this. That's as far as I could get, and then I have to look up how I did it before. Okay, so it's actually, let's just keep it simple and just do a traditional way. Double start, double total, and then just construct start, total. Ugh, come on. And then we'll also have a default constructor. See if that fixes it. Nope. Maybe I need to read this more closely. Never saw my game before? Well, cool. Or just remember, it's a work in progress. There's not much you can do in the game. It's mostly a test framework. There are some test NPCs. You can actually talk to George in the game and ask him for help, and he'll get stuck trying to get to these slimes, but if these slimes aren't here, he'll walk you across these two bridges to the way out of this level. I can demonstrate what happens if I put the slime on the correct side of the water here. And did the game just freeze? I think it just froze. Yep, game froze. Interesting. The game chose that moment to crash. But it's pretty resilient. The game comes back up. We're all good. So yeah, when you place these slimes near him, he fights them and chases them down. And he leaves behind the loot there. Am I using C++11? Yep. If you provide defaults for the struct arguments, you don't need the braced initializer. That I thought it would just work, but maybe not. It just doesn't know how to initialize it, right? It doesn't know how to turn that into that structure. Okay, just out of curiosity, can I call that explicitly? Can I just do that? No, there's something else then. What else? What is the problem? Oh, there's no comparison operator. That's the problem. It was telling me that all along. I just didn't see it. Okay, I know how to fix that. That I just need to provide one. So bool operator equal const auto other. I can't say auto. Thank you for the follow, by the way. And then we can just say return start equals other start and total equals other total. And did it build that time? No. Wait, did I do that right? No, this should be const. There we go. Built. One of those obscure things that like the compiler errors are very hard to interpret. So it was telling me all along that it could not, that this macro expanded to be comparing map keys and values, and it didn't know how to compare map values because it didn't have a comparison operator, because there's none by default. So I think I can get rid of this now, right? I can probably reduce that to this, and I might even, just like iGrok said, I could probably even remove the constructor. I can see what happens. What happens without the constructor? Well, I guess it works for now. So it doesn't need the constructor, it just figured it out. Okay, but does it actually work? No. Okay, so I'm gonna need, when you get this in Google Test, it means you need a printer. So there, it's called a print2 function. And you just need to make one. So kind of like one of these. The support function for a Google Test. So what you gotta do is you gotta declare it at the global scope, is that right? No, I guess I can declare it inside the namespace. So you do that and then put that there. Support function for Google Test to print out values of that structure. And this is function information. This is the function information value to print, and then we'll implement it. So OS stream is declared in S stream, I think. Don't quote me on that. And the body will need to be up here somewhere. Where exactly would be the best place? Probably near this one, like above that one. Yeah, right here. All right. Print to, and it's pretty simple. You just print stuff. So I'm going to print a bracket. Actually, let's print a whole string. Say start equals, and then function information dot start. And then comma, total equals function information total. And we'll end with another bracket. So these all need to have DVD reference. I don't know why they use a pointer, but they do. Now the broken test should print out something I can read. Oh, okay. Why? They actually are the same. Why does it say they're not the same? Oh, I wonder if it's epsilon stuff. So that could be. When you do math with with floating point numbers in general, you don't all it's dangerous to do where is it? Why did I do? Yeah, it's doing exact equality comparisons between doubles can lead you into trouble. So, and I really shouldn't have defined it here. I should have defined it outside. Really should do it here, right? This goes there, and then I can just say that. Okay, and let's fix this. So really the better thing to do would be to say that that minus that is less than. I need limits for this. Less than standard numeric limits of type of decal type start, I guess, dot or colon epsilon times 2, I guess. Kind of weird, but that's what you do. How come it doesn't like this? Is it because I need to call that? Is it a function? Yeah, okay. Sometimes they have them as constants in the namespaces of the standard library. Sometimes they're functions. So same thing with that. Let's compute that once because it's ugly. So static const. I don't know what we want to call this, max error. It's that, and then just make sure that it's the difference is less than the max error. Can I not do that? Oh, const auto. And let's just be a little bit forgiving and do that. And put that, and we should be good. Probably use ABS. Oh yeah, probably. You got me there. That would have been a problem. It's FABS, right? Fabs. Why don't I do multiple cursors? That is in math.h. And if you think I'm crazy because I mix C and C++, I just say I do it because I can. I don't have to use the C++ ABS if the C one works just fine. I could also use the C equivalent of that because it's fewer characters, but that's okay. It doesn't matter. There we go. So we fixed it. So let me break it on purpose to make sure that this isn't screwed up. I'll put that to like, I'll just add a 1 to it. There we go. So that should break, right? Yep. So it's saying that it's different. Okay, got it. Cool. C++1 was, please C++1 would automatically choose the double. Yeah, as long as I did that decal type, right? This decal type. In fact, I like to make that appear more. This is a cool thing in C++ you can do. That way, if I chose to make this to float, it automatically changes this to use the float epsilon instead of the double epsilon. See that? It says float. But if I went here and I made it double, now it's double. Look how magical that is. It basically says that variable, put that variable's type right there in that template argument, and then use that epsilon. So it's kind of cool. It's similar to auto, where auto is just figure out the type. This is take the type from that guy. Oh, I didn't see that stuff from Miyazaki. A contract for Bulletville. Refining a behavior tree, you need to port the BT services into C++ because they are a bit too heavy for BP script. That's probably my future as well, right? I'll probably find with all this stuff that just the pathfinding stuff is just too slow in Lua, and then I just need to put it into C++. I'll probably get there, right? Okay, so now the instrumentation code makes reports that will look like this. So for every function, it'll tell us when it was called last and how long it took. So let's go a step further. Let's say we want not only the last start time, but maybe the number of times it was called. So let's have it call bar twice. Sound cool? So let's say a little bit later, like 4 or 5. Let's have it take a little less time. So let's include a call counter. So that will be 1, and this will be 2. And then let's make just out of kicks. Let's keep that as the last. Actually, hold on. These will be the last variable, so that the last start time, last duration, maybe. Actually, I don't need that. I don't need that variable. The last start time for bar then would be 1.45. Oh, wrong one. 4.5. But let's do minimum and maximum. So 0.1 and no, sorry. 0.6 and 0.6 for minimum and maximum, and then bar, it's the minimum would be 0.5. Maximum is 1, right? And then let's have a call counter. Foo was called once, bar was called twice. Soon I'm going to want to make these have member-wise construction or names, because it's going to be hard to read that. So that means I got to change what's in a function information. So we're saying that we want to have a size t of count. Count of what? Num calls. And we're going to make this, instead of total, it's min time and max time. I have to start thinking about what if it's recursive. Because if we recurse into a function, so I might want to have like a stack of some kind. Instead of recording the start time here, I might want to have a stack that remembers what function is at each level of the stack, and then as we get back to a function, we would pop the stack. But we'll get there. I'll do that in another test where we test recursion. Okay, so I need to go into here and change this a bit, right? Because this now has a num calls equal to other num calls. I cannot type right now. Min time goes there, and then we have another one for max time. Failed because total is used on line 331. So let's just say const auto total, and then we can say function info dot. I know I initialized the min and max wrong too. I'll have to fix that. This should be minimum of this and total, and then the max is the max, right? Max. I just need to fix the initialization here. The minimum should be standard numeric limits of decal type min type. I wonder if I can do that in its own definition. Maybe not. Maximum max, actually, right? Maybe oh, min time. Oh, hey, I guess I can do that. Scripting works well for fleshing out ideas. Yeah, so that's what I'm finding out. In my game, I already closed it. In my game, I've been fleshing out these ideas, and I have updated Georgia's script, for example, to use A-star pathfinding for just about everything. And I can't push it into production right now because it's really slow. So it was good for fleshing out the idea. I can make sure that the logic works, but then before I put it into production, I need it to be fast enough. You're back from classes. Welcome back, A squared. I'll give you a third wave since you're back from your classes now. Wow, today is really funny. Like, for the first hour and a half, we had more bots in the chat than we had humans. Now we have a lot of humans. I guess I have to thank all the people who rated. I know you got 3 waves. Isn't that cool? Yeah, thank you everybody who's been rating and hosting me. That's really kind of you. Let me fix this by compiling again. Okay, min and max are declared in algorithm. That I've pretty much memorized. Okay, it's still using total on line 77 of this one. Right, so when we print it, so that should be like count, min, time, max time. There we go. Oh, it wasn't count, was it? It was num. I can't remember now. What did I call the dang thing? Num calls. There you go. All right, run them. What's different? Oh, I did not increment the call counter. Okay, so that's default start. No, default before instrument. So I need to increment. So plus that dot num calls, which means I can do the same trick to get a reference, and then use the reference there. And to be most fair, we should probably do the time check as late as we can, and that the after we should do it as early as we can, right? Yay, we pass. Okay, cool. All right. Less bot-like than my bot? Yeah. Well, we all know that iGrok is a bot, right? I'm just kidding. Okay. Slowly but surely, I'm getting the stats that I want. So this is the last call, which I'd like to optimize. Well, we're going to get rid of that, right, in a second. Number of times the function was called, minimum execution time, maximum execution time. I'll want to have an average in there, but first let me handle recursion. So this, I want to make a special test for this one. So default instruments recursion. So same kind of setup, but instead of bar, we'll have it re-enter foo. And this is mostly a separate test to keep it looking simple. So like at the cost of there'll be multiple places if I change the report format, and multiple places have to deal with it. Actually, if this is only cares about the recursion, I could be more specific than that. I can say expect equal the total time, right? Let's keep it simple and keep it just single digits. So it should only be one. Should I call it 2 calls? It should be technically 2 calls, right? Let's get access to it. Const auto foo info is report function info, and then go to foo there, and then for foo info dot, you can do it. Why can't it do it? Oh, because no, I can't do that. Why can't it do that? Why doesn't it let me do that? References must be initialized. Oh, because it might not be const. In fact, I need to do that too. It might actually create the record if it didn't exist. If I really wanted to be const, I can't do index. I have to do like find. And then I'm dealing with an iterator and not the actual value, and it looks gross. I'd rather just remove the const because it's in a test. So they can do expect equal 2 for foo info dot numcalls. And then here's the trick, right? Is the outer call will be 0.4, so I can expect near. That incorporates the epsilon into it. So near 0.4 for the max time, and then the min time should be the inner one, right? For the min time. And then I can drop the rest of that and just test with this recursive case. Okay, it didn't like something. Oh, it wants the error in there, right? So the error will be standard numeric limits decal type foo info.min time epsilon, I don't know, times 2. We can be generous. Let's, I was going to say let's make it shared so I don't have to do this, but then theoretically these could have different types, right? So this should say max time. Alright. Anyway, let's run it. It's going to fail, right? So it's going to say it got called 3 times. Oh, because it did get called 3 times. That's a bug. It should say it got called twice, but the time should be wrong, right? Yeah, so difference between 0.4 and max time is 0.2. So it didn't get the times correct because we only had one shared start time. So I need to get rid of that because it doesn't handle recursion. So we will enter the before and then we'll re-enter the before for the same function. So I think what I'll do is I'll have a stack just to mirror the actual Lua call stack. Function in, I guess we'll put it next to report, I guess. So call stack. And then I need to make a type for that. I guess I'll put it in its place right here. Types. Using call stack is a stack really of what's call stack location. And so we need a stack. You don't use stack very often. It's not always that useful. So then this is a struct, because what do I want from it? Actually, what I know what the function is. I really just need to know the time, right? Yeah. So we'll just put it here. There. Could you easily have used Python instead of Lua? I used Python in the past, embedding Python instead of Lua into C, C++ programs. And it's fine except for the standard library is a lot larger and harder to deal with. So you can't embed it in the executable very easily. There are some solutions out there that'll do that by taking it as just a byte glob and gluing it into the exe somewhere. But Python really likes to find its standard library stuff in the file system. So along with the exe, you have the baggage of all the Python standard library files. And it was just very clunky. Like you really can't have Python without its standard libraries. Like a lot of Python just breaks. Whereas with Lua, it's really easy to include the standard library. You just say open libs Lua, and you've already compiled them in if you include those headers and you compile the corresponding .cs. So that's the main reason I switched to Lua. Is before Lua it was Python, and Python it was just a lot of baggage to bring the standard library around with you. Okay. I put the start in the call stack location. I have the call stack there. Okay. So then I just need to change how the instruments work. Default begin. So we're going to push something onto the call stack, right? So call stack load. How come it's not finding it for me? Because it's in impl. Impl call stack location. Just call it call. Call.start is current time, right? I guess I want to do this last. And then push it, right? So call impl call or self call stack push standard move call, and then we're done. Why is it not like that? No instance of overloaded function push, blah, 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 matches the argument list. Argument types are remove reference. Object type is calls. Wait a minute. Why did I have the wrong type there? No, that's a stack of those. That's one of those. So why can't I push that? Maybe it's just IntelliSense is confused. It's just IntelliSense. Stupid IntelliSense. All right, so I don't need the start time anymore. Let's remove it. Back, and then I get rid of that. And then the after, instead of getting it from there, it's going to get the top and then pop it, right? So yeah, I can just say const auto call equals self. Actually, I have to do this after we have self. Self call stack top, and then const auto start. I guess we could do it last. We can just say self call stack pop last, and then we have the finish time, the start time. I did that wrong, didn't I? It should just be call dot start. There we go. Unreal Engine 4 blueprinting is so much easier to read. I'm sure it is. Code is hard to read until you've gotten used to it. And I've never gotten used to reading compiler error messages. That stuff like that I can figure out. It's like, oh, I'm still using the name start somewhere. Right here. And oh, I did make that mistake. I shouldn't do that because these could potentially be different types. So I really should bake that in, shouldn't I? And there's no more. That's no more. I don't need that. And that's min time, and that's max time. Yeah, I don't think we can condone that. That's not legal here where I am. Okay. Oh, back in my test framework, it doesn't like this because this changed. We removed those two. Yep. And there was the other test did it too, right? Did it? No, wait a minute. What's the problem now? Start isn't defined back here. Oh, in the dump. So we can just do that. Cool. And hey, it looks, it works. So the recursion case worked, and I can run the other test too. Cool. I wonder if I should make a test for the set clock now. You could argue that I don't really need a test for set clock because these other tests test set clock already because we're calling it as part of the instrumentation. So maybe that's what I'll do. I'll reason that set clock is tested by the other tests as a side effect. There we go. I've justified removing a test. I'm a horrible person. Yeah, the laws might be different from where you are, but I can't, since it's my stream, I can't go along with it. Sorry. Can't condone it. Sorry. I be restricted in my terms of service with the Twitch and all that stuff. TOS. Okay, so this handles minimum and maximum call times, number of calls, and it handles recursion. So what's next? Maybe I want an average call time, and I also want to know what other functions it calls. Yeah, Monka TOS, I know. Yeah, we should probably limit the discussion about drinking alcohol. Otherwise, I'll have to remove the family-friendly tag and all that. We don't want that. Okay. Should do the average times next. I can include it in this right here because bar is called twice, so I could just include the average here. It's going to just be an overall average anyway, so it should be simple. So that should be, let's put the average right in the middle. The average would be, quick math tells me it's 0.75. And we should go ahead and do the same thing here, right? The average between 0.1 and 0.4, quick math tells me it's 0.25. So average time. So I need to include an average time. Average time, it's a little tricky because actually we won't have it be average time. It'll be total time, and then you get the average by dividing the total by the number of calls. Total time. The total time would be 0.5. And then this total time would be that, and the total time up here would be 0.15. Did I have the number wrong before? I did have the number wrong. It's actually 0.15, isn't it? And half of that would be 0.075. I had it completely wrong. Anyway, now it's right. Total time should start at 0. Okay, and what else? Need to add to it every turn, right? Or need to get it to compile, I'll need to include it here. Well, I don't need to include it here, but we'll do it anyway. Okay, and then probably the comparison too, right? This one, yeah. Total time. So it won't pass yet because we're not accumulating it. So min right here, we just need to add to it, right? So function info dot total time plus equals total. So when you get down to it, the actual instrumentation code is not that big a deal. We're mostly just looking up a function and then updating information about it, right? This one, we're just counting that it was called and recording the current time and putting something on the call stack. And here we're popping the call stack, getting the finish time, getting the difference in the time, updating our statistics about it, right? So I feel like we're starting to get some benefit from the infrastructure I built up because it's just working. All right. So we have minimum, average, and maximum and number of calls. Now I want to have who called who and how many times would be nice, right? Who called who and how many times? All the Lua interrupts seemed huge. Yeah, it was huge. Huge. In fact, I need to probably go refactor it. I'll show you some of that ugly code. Here. The unwrapping and the wrapping. And oh my goodness, he's using closures. Closures, up values. Yeah, the instrumentation, the interop stuff was a really big part of it, right? Just getting the functions to be instrumented, and now we just have a hook in to instrument them. Finding functions in Lua and skipping the ones you're not supposed to be looking at, that will lead you into trouble. Where was that? It was the G. Where was that? I could have sworn I had a table of it somewhere. Here it is. It's in do not search. Don't ever search these for functions because you'll end up recursing in these two, and you'll mess up Lua. Anyway, yeah. We'll button up those scary functions because we know that they work now. Right? Don't need to ever look at them again. In fact, this one I think is obsolete. We could probably drop that one now. I don't think I need that anymore. That was only while I was first starting out, right? Yeah, I can remove this one. One less thing for me to worry about. Drop it. I don't even need to comment it because it's gone. Goodbye. We don't need it. Okay. Who called who? That should be something the default instruments do. That should be in this table here. it's going to be, I guess, a map from path to what? Just a number right now? Oh, we should also get the amount of time. That would be nice to know. So, for every function, how long, what it called, how many times, and the total time that it was taken. So, for example, foo calls bar twice, right? Would it be good to illustrate this in this simulated test case? We have two functions, foo and bar. Foo calls bar twice. Foo, bar, bar. So, some more ASCII art here. Foo, which calls bar twice, and then returns. There we go. So we're calling foo, foo calls bar again, and then returns. I guess let's have each of these be a different point in time. So, time, caller, callee. And do it this way, I guess? Thank you for the follow, by the way. How's the Lua going? Pretty well. Will you instrument callbacks to C++? Yes, I will. Because callbacks are themselves Lua wrappers. So they get instrumented too. Oh, you enjoyed my stream? Wait a minute. Okay, you were a lurker. Well, that's fine. You don't have to say anything. I'm glad you enjoyed Virtual Kernel. I like your name. I'll wave to you. Good night. Oh, and Dota Prodigy, hi. I forgot to wave to you. You were talking about the minimum build for Unreal, right? And Fargo Bitwise? I think you got unlurked for a while there. Hello. Okay, yeah, I'm just mostly documenting this test case so people following along know what's going on. Whoops. My kit slipped on the keyboard there. Foo calls bar. And then again. And then well, the arrows don't really make sense. Let's just make this a call time. Yeah, let's just do it this way. And then I can sort of drop these out and maybe making it look like that would make more sense. And then the time, that's 1.0, 1.2, 1.3. Oh, that's 1.45, right? And then there's a return call at 1.3, 1.45, and then the return call at 1.5 goes back. Let's do that spacing to make it look a little bit better. And then this happens at 1.6. There we go. And then a little bit more space. And then maybe a little bit more here. Put the call there. This is a little bit more indented than it needs to be. I don't know. It's kind of toying around with this. Gives me a little bit of a break. Oh, I'm getting a phone call. I'll be right back. Okay, that was Mrs. Reimer calling to say that the car's check engine light came on. So we gotta get our car checked out. Would it make more sense if I actually say foo here? We go into foo, then we call bar, then we return to foo, call bar, return to foo, return. I think that makes more sense. And then that just looks better. Okay, cool. I'm done with that. So, in terms of information here, we're going to have more information. It's going to be some kind of collection in here. And what will the collection have? The keys will be paths. So, for example, who we're calling. And the values would be, it was how many times and how much time, right? So another structure, 2 for a total of 1, 5. So bar doesn't call anything, so that's an empty, so this whole thing is empty, right? Foo calls bar twice for a total of 0.15, right? Right. That's 0.1 plus, yeah, so we should say, total time, time. So that would be 0.1, 0.05, and then the total there is 0.6, right? So the idea is you could take that minus that and know how much time was spent in foo alone. And then if this is the amount of time spent in bar, that's how much is spent in both of them total. And then the difference between those two is the amount of time spent in foo alone. I've lost you? I'm sorry. I even drew this nice ASCII art to explain the test scenario. 2 functions, foo and bar. We call foo. Foo calls bar, returns to foo. Calls bar again, returns to foo, and then foo returns. That's the amount of time that the call to bar took. That's another 0.5, so the total is 0.15. There are 2 calls for 0.15 total. And then foo returns, and that total time is 0.6. So that these numbers come from the difference between that and that is 0.1, between that and that, and then for foo, it's between that and that. So if you want the time that foo took by itself without bar, you would take foo's total time and subtract the total of the bar time. So that's that plus that. So it would be 0.6 minus 0.15, which would be 0.35. 0.45 would be foo alone. So that's the extra information I want, and it's, do I want to include that in the recursive one too? Probably should not care about, actually no, we should record that foo called itself, right? Yeah, so we should have something in there, so that it would be, foo would have an entry noting that it called itself. I guess we could put this structure directly in here. What's it gonna be? It's gonna be a map from moon clock path to moon clock, whatever the heck this is. It's not a function information, it's like a calls information. It's the specifically one function calling another. How many times and how much time, right? Oh, and I never tested to see can I remove those parentheses. I'm gonna guess that I can. See if I can get away with it. Looks like I can't because, well, actually, I don't know yet. Let's put the parentheses back for now. I'm gonna see if I don't need them here though. Foo info dot calls info. Or should I just make it calls? Calls. Okay, so I need to have that somewhere. Actually, this whole thing is calls. So that goes here. Maybe I should make a type for that. Okay, I don't need to say that again. But I do need to define that, right? And that needs to be in the interface here. I think I am going to end up making a type for this. Calls. If that's for one caller, then for all callers, what is it? I can't think of a word. Maybe I just don't give it a name yet. So be explicit here, but I need the other one to have a name. So using, or no, it's another struct, right? Struct calls information. It's got num calls and total time. And it's got a comparison operator. I've been using C, yeah, pretty long. 24 plus years. Well, it says 24 years at the last company. I can just tell you that before that last job I had an internship that lasted over the summer. So most of my experience has been the last job I had. Uh-oh, Monka S. Is that good or bad? All right. This comparison operator, but slightly different one for this structure, has only those two things in it, and I guess, yeah, we'll want to print 2 for it, right? How about making this function information a recursive data structure instead of having a separate calls information struct? I don't think I need all that information, though. Like, will I really care about the average time? I mean, maybe. Maybe that's what I'm going to end up with. Thing is, it's not going to nest. This thing won't have another one of these because that call has its own function information separate. I'll keep your idea in mind. Let me take this and putting it here. It doesn't feel right, but I could be wrong, and if I'm wrong, I'll come back and do that way. It just feels better to have this be a leaf node right now. And not make it recursive. Like, I just don't think I need that to be recursive. I could be wrong. I'm probably wrong. More than half of the time, I'm wrong. That's fine, right? It's fine to be wrong. You learn better that way. Print 2 goes up here. It doesn't take me that long to change this stuff anyway. And that is just, yeah, that. Okay. So, what do I expect here? There'll be an entry for foo, and it will be 1 call, total time of 0.1. And that's it, right? I think maybe I do need those extra parentheses. Because when I remove them, the red squigglies appear again. It's a thing that has to do with the way Google made their macros. Okay, it didn't like what? This one up here? Oh, that's because it's not in the comparison? No. Oh, it didn't know how to make an initializer list entry for that. Is that because it's not a simple type anymore? I think it doesn't know how to initialize that. I need to stretch. Compare doesn't take 3 arguments. I think it's just that's confused because of that. It just doesn't know how to make. It just doesn't know how to figure out with that initializer list. Okay, I'm gonna guess that because that's not a primitive type that I need a constructor for it now. So let's make a default one. And let's make one that's not default, that has all this stuff in it. Kind of tedious. And I'm just really guessing if this is it. See, this is a lot of the time I just guess things in C++ that seem right, or seem like what they should be. Min time, total time, max time. We'll make that make it so if we're given it. Actually, I might as well just make it an R value reference at that point, right? Because that's the only time I use it is in the tests. So then that could just be moved in like that. And then I do need to update this to compare those two. So, and calls equals other calls. Yeah, I don't think that helped. It still doesn't like that. What did I do wrong here? Do I really need to call it like a constructor? Like that? Hold on, what? Okay, I must be missing something. I'm missing something. Because that didn't help. It's still saying it just can't initialize it. So what am I doing wrong? Can I do it this way? Let's see. Foo calls info. So const one of these. I think that's the problem. I can't do that. Oh, wait a minute. This should be in front of those. It's been from in all time foo and bar. Is it this part that I can't do? Const that. Wait. Hold on. That should just be like foo calls, right? Who calls? Foo calls. So that's okay. And then can I do that then? No. There's something wrong with that. What is foobar? I think it's F-U-B-A-R. F'd up beyond all repair. But I don't know for sure. Okay, there's something wrong with assembling that. Do I really need a constructor here? Like I do for this one? I was doing that fine before. How come it doesn't like it now? Oh yeah, that's okay. It doesn't like the map though. But I was doing the map construction finer earlier with that. Oh, wait a minute. It's because I did standard move, right? Standard move that, right? Or am I getting confused? Nope. Where did I do R value construction? Oh, that's for that one. Yes. Okay, so it wasn't for that. But maybe it's maybe I need to do a similar thing. Okay, well, let's just see what happens. This is probably wrong. Just see. So then that, right? It still doesn't like it. The heck? Maybe an extra stuff? Oh, right. Yeah, hold on. I see what you're saying. Yeah, that should have just worked, right? Why doesn't map let me why can't I construct a map like that? So I really didn't need this, because I was able to construct it just fine there. Why doesn't this line work, though? It's off the screen, too, so it's hard for you guys to see it. If I do that, maybe you can see it all. Yeah, what's wrong with this? It can't be this const, can it? No constructor could take the source type, or constructor overload resolution was ambiguous. More brackets? Okay. No. Oh, wait a minute. Yes. Yes. Okay. iGrok, you got it. I think I realized what I did wrong. I should think of it this way. It's a map, and these are the keys. These are the key value pairs, and that's a key, and that's a value. So then I should just be able to place that in there, and it still works, right? Yes, and so again here, that whole thing should fit in there with extra brackets. Yes, that was what it was. Okay, so then I didn't need this constructor after all then, right? Guessing? Yeah, okay. That was it. The whole time, it was just extra brackets. Give iGrok more points. Round it up to 5 points. Yeah, it's confusing as heck. That because I'm digging my own grave by having a map of structures which have maps of structures, which maps of structures of maps of structures. I really should just start indenting all that crap. Anyway, it is what it is. It's compiling now. It won't work because those things are missing in there. It's nice that the print2 works correctly. Actually, what's different there? Hold on. This... Oh, the print2 isn't including the information. That's why. So this should have like calls in there. Yeah, can't assign yourself lots of points. Nope, doesn't work that way. Oh, we can't shift it out? Why not? That's not supported because I gotta do a print2, I guess. So I gotta do what? I gotta do print2 this comma OS. None of the two overloads convert the arguments. Why not? Why is this so hard for me to do? Oh, it's a map. Right, there is no... Right, so it doesn't handle that. There's probably a Google macro that I gotta do to make this work, right? Maybe I just need to figure that out. They probably have some kind of wrapper that does that, and I just don't know how to do it right now. Reminds you of a web app you did before. We did results of data. Yeah. I guess I could look into how these macros are made. Like, what does this do? Can I go there? If I search that, I'll have to take out the exclusion for Google test for a minute. Okay. Whoa. It's in Python. How did we get into Python? Wait, this is Python. Wait a minute. Is it all inside this header then? Oh, that's an I'm just being dumb. That's an argument to the macro. So it's all in this helper, I guess. This helper. So yeah, what is it? How does it print? Format for comparison failure message. Format for... So is that what I want? Format for comparison? T1, T2? Print toString? Is that what I want? That's probably what I want, right? I'm guessing that's what I want. So let's try it. Print toString that. Because that's a string. I should be able to shift it out then, right? It doesn't like it. Testing is not a member of the global... Oh, because... Oh, shoot. I can't get to it because I don't have Google Test as a direct dependency of the unit. Grrr. Well, I can just do it the old school way. How does it done right now? We don't know. I can look at it here though. So they have parentheses, then the key comma, value. Got it. Okay, so I'll have to do vector and map stuff, right? Oh, shoot. This is going to be painful. Okay, we can do it, though. Toughen it up. We can do it. All right, so we do OS parenthesis. At the end, we're going to do an end parenthesis. And then we're going to do a for const auto entry in function information.calls. And then we'll say OS, it wants, for the vector, it's like this, right? And the end will have a space that. And then we'll say for const auto step in entry dot first. Shoot, let's say bool is first step true. If not is first step, then OS has an extra comma. I'm assuming it's comma space. Set it to false and then shift out the an escaped double quote and then the string step and then another escaped quote. And I won't worry about the encoding if it has escape characters, and then I'm not going to care about that. Actually, that's probably okay, right? That's going to do all the keys, and then we'll want, and then it's just print to. So print to function. Well, it's not function. It's entry.second to OS. Right? Yeah, painful. Okay, so there we go. I can see it now. The calls should have had that, and it's empty, and that looks reasonably the same as what Google. So if I was big brained, I'd probably figure out how to get Google Test to do that for me without having to make Google Test a dependency of my library. But I don't know how to do that, so we'll just drop it. So the test is set up. It's showing that the information's not there yet. We need to add it. So let's add it. That's in default before instrument. We need to, well, we're setting up a context on the top of the stack, right? So we can look if there's already one on the top. So we can say if, oh, it's that same robocaller from yesterday. Have my voicemail, robocaller. We can say if not self call stack empty, then we were called by someone else. So we can go into that. We can say call is that, and then call dot. Oh wait a minute. I don't have anything in the call stack. I will want to add it though, right? Right. What was in my call stack right now? Oh, I said I didn't put it in there yet, but I was maybe going to add it. It's just a start time, but if we had the path, then we could find the other function. So let's do that. So path, path, easy peasy. Empty. When I fill it here, so call.path equals path, right? And then we can get it back here. We can say auto. I need to be careful about that. I don't use the same names. What if we call this caller? Caller call. Does that remind you of, again, of data.data? Caller.call? So this would be caller function info. And so we're going to pull from the report the function info, but the caller calls path. let's make this a little bit easier to understand. Caller call stack entry. So the call stack entry of the caller. We're getting the path out of that to look up their function info, and because we're gonna go look into their callee call info is the caller function info dot calls reference our path. Callee call info dot numcalls plus plus. And at the end, we're gonna want to put the time in too, right? So and what is this? Why is it say I can't push that? That's not a bug. That was an IntelliSense slip up. Okay, so we need to account the time too, right? So we have the total there, so we could do it here. If it's not, actually, we want to pop it first. Now, if it's not empty after popping, we get to the caller, and we know our own path again, and we're going to add to the total, right? Total time plus equals total. There we go. Done. See if it works. Yes. First try. Makes me so nervous, though. Okay. So now we record what functions, a given function, for every given function, we know what functions it calls, how many times, and for how long. This is good. So, what else do I want to know? That probably is good enough to start with. I think I could check that in and then move on to the next thing, which was that right now it only instruments functions found in tables. If we want to support things like C++ functions called from Lua, we'll have to support functions that have these meta methods so that we can instrument them. Nest more maps. Yeah, I'm done, so I need to do mappings of more maps, and then I got to wrap the maps of wrappers. We're going to make a wrap about mapping wrappers who make maps to wraps. It's a snap. Mapper wrapper. Yeah, I think this will be useful. Actually, by itself, it'd be a fun thing to try instrumenting like just a normal Lua function. Maybe I can look into doing that right now. So something that does Lua already would be like actually, I guess it would make sense to just make a test main program, right? That is like Lua, the Lua command line, and then but when it's done, it would just emit a report and say how long everything took. Would that be a smart thing to do? Mapper wrapper should be the outermost parent. I'm wondering how much use I'll get by making a main program that tests that I can use to run this stuff, versus just try to get it to instrument essentially non-tables functions that are in things that aren't tables, and then that'll allow me to instrument the actual game core, like all the callbacks into the rendering system and stuff like that, and then I would just include it in the game and then figure out how I want to report it all. I kind of want to have some intermediate step though, so maybe that's what I'll do, and I'll save this for next week, I guess. So it would be write a simple host program that lets us run Lua and let's say lets us run a Lua script and instruments it gives us a command line kind of thing, and at the end generates a simple report. So I can take as an example what the Lua main program does. The CLI for Lua. I think it's really, really simple. Let me find it. It's like lua.c, I think. I think the most difficult thing is that they have like an interactive mode. But yeah, essentially they make a new state, then they call a p main, and then when that ends, they close Lua interpreter and just exit. And their p main, I think, just sits there and it's like reads input and then runs it. Yeah, it's more complicated than it needs to be. I made a simpler example of this, didn't I? You know, what if I just kept it really simple? Instead of giving us a command line, instruments it, runs a function, runs a main function. How about that? Runs a main function. At the end, generates a simple report. So that's bare bones simple. It was just load a Lua script, expected it to be a main function, instrument everything, call the main function, stop instrumentation, generate a report, and return. I like it. Okay, that's what I'm going to do. Maybe even make it part of Moon Clock, maybe example or something. Let's do that. So a new folder called example. And then the example would have, similar to the test, it would have a CMake lists. And that CMake lists would say Moon Clock example. And then we can just have it have a main. So it would have a source folder with a main.cpp in it. And this isn't a test, this is like an applications. I need to make it the same as one of my other standalone apps, like AWS Play. Yeah, applications. What else do I need? I need this top level junk, right? Where I typically have that after the link libraries instead of the add tests. There we go. It's just going to use Moon Clock. Not going to depend on anything else, right? Probably don't need anything else. Batcraft! Batcraft, thank you for the Prime sub. I appreciate that. Although I feel like Failed to Survive would probably be a better sub, but thank you. Hope you're enjoying the stream. Hey there. Tamat, how are you doing? Oh, and I forgot to wave to Atomic Nibble. Oh my goodness. What kind of waving person am I if I forget people? You already have a gift sub to his channel? Ah, well, thank you very much. I appreciate the support. Moonclock has a dependency on a timekeeper, and System of Abstractions has a default clock thing, so I'm going to use that, and that's going to be our dependency list. So let's just make this main. Let me steal another main program. That'd be make it easy, right? Newman was a nice main program. Can I just steal that? Let's just steal Newman and call this. We're going to drop most things here. This is going to include Moonclock, and it's going to include System Abstractions time, and that's about it, right? Time. And that's about it. I think. Well, we'll probably want standard I/O. And we'll probably want No, we don't need signal. Probably want these ones. Yeah, this is probably what we want. Okay, and I need to make sure that the top level here does another subdirectory, for example. Subdirectory. Example. I'm doing okay, Backcraft. How are you? Leave main alone! You're 14, you know Java and C++, and you want to learn machine learning, should I? You should if you want to, if it's something you're interested in. And then one language that's really popular in machine learning is Python, and I like to encourage people to learn Python. If you already know in Java and C++, the only thing about Python that might throw you for a loop is the syntax of the indentation style. That the indentation style is The indentation is used for scoping, so that's the only weird thing. Otherwise, I think you'll catch it on. You'll catch on to it, and machine learning. A lot of tools out there for machine learning are done in Python. So the answer to should you is if you find it fun, then yeah. I think a lot of things in life are answered like that. When someone says, should I do something? The answer is if you want to, or if you need to, within the rules of society, I guess. All right, let me get back to this. Well, I can drop all of this junk, right? Should I have a print usage information? I'm slipping on the keyboard. Print usage information. We're gonna say moon clock test. What are we gonna require? Script. Sure. And maybe even the function. So load a given Lua script. Instrument its functions. Call the given function and print out a report on performance metrics associated with all Lua functions found. A lot of them are going to be zeros, actually. I wonder if we'll want to omit the zeros. Script. Path to, let's add more spaces. Path to file containing Lua functions to execute. Lua functions to execute. Function. Name of the Lua function to call. There we go. Keeping it simple. Well, that's why I said backcraft. That's why I said within the rules of society. So that kind of brackets it, right? I don't need a shutdown environment. We're going to have... You know, I'm not even going to bother commenting too much, am I? It's just going to take time. Actually, I want to publish this eventually, right? This is the path to the file containing the Lua functions to call, and this is the name of the Lua function to call. So this will be script path, and this will be function name. All right. Don't need an interrupt handler. Here's our traditional main. I don't need the environment. Oh, wait a minute. No, this is not the main. This is process command line arguments. So I'm not going to bother with the diagnostic message junk because I don't think I need it. I'm just going to use printf. Okay, so script path is one variable. Script and function, right? Script function name script path set function name set. These are just to make sure it gets called. Actually, do I even need that? I don't think I need that. I don't need those. Remove those. It's just we need to end up in state 2. And we'll just do printf standard error, extra arguments given, return false. Okay, and then we'll say if state is less than 1, then print the standard error, no script given. Return false, and if state is less than 2, no function given. Return false, cool. And then don't need any of this junk. I just need the main program at this point, right? Yep, so there's the main program. Okay, what does it do? It loads a Lua script, instruments it, calls a Lua function, and finally prints out a report. Prints out a report generated by the instrumentation. All right, and then we don't do that. Okay, and this is standard stuff. There's an environment. We don't buffer standard output. I don't need to do that. There's no publisher. And ultimately we'll return success. Let me just make sure that this builds on its own. All right. What did it do? It configured. It's building. It built it. So I can run it, right? Build and VS Code, and then go to moon clock, and it should be here under example. There it is. No script given. Okay, I forgot to have new lines here. Okay, so let's give it a script. Foo.lua. No function given main. Okay, so it doesn't do anything. So let's pull in Lua. So same way that the tests do, we'll just include Lua. And the same way the test setup works, we'll make a Lua interpreter in main. And I'm not even going to pull in the comments. We'll just pull in the code raw. The raw code. Pull in the standard library, and then ultimately want to close it. And I'll need the Lua allocator. Say I'm a master at copy pasta. Allocator, reader state, yeah, all this stuff. Traceback, this is all good. I'm even gonna want some of, no, maybe not that. This is good enough. So pull this into the anonymous namespace too. There, so we got the Lua allocator. So now we have a Lua interpreter. I can ask the Lua interpreter to do some math for me if I wanted. Like, I could say Lua push integer Lua 2, and then 3, and I can say Lua add. Actually, it's operation, right? Actually, how do you... I know how to do compare, but what's the function to have stuff get added in Lua? Just out of curiosity, is it perform operation? I should know this stuff. Okay, Lua add from C. Okay, maybe it's not, maybe it's something we can't do. Okay, forget it. I was just going to say, look, we have a Lua interpreter. I can add 2 plus 3. Okay, let's not do that foolishness. So what I really want to do is load a script. So there are a couple steps to that, right? Got to open the file and load it. So where can I copy that from? Newman did it, right? Didn't we have an fread or open? Email file name. We definitely read it in from there. Where did I read it? Oh, we just use ifstream. I don't like ifstream so much. I guess I could do that. Just read it line by line. No, I'd rather just read in the whole thing as a block. Server host definitely did it. Let's find that. Read file. Oh, thank you for the follow. Can't add 2 and 3. Now, I don't know how to actually invoke add in Lua. It's funny. You can't actually do everything from the C API. You can like call things. So I could make a function and then call it, and the function could add 2 and 3 together for me. Here we go. This is what I want. I want to load. This is too complex, though. Isn't there a simpler one? Maybe one of these without a diagnostic message handler. So plop that there. Yeah, I don't need a file description or Contents, let's just say if it's not empty, then it's not an error. So let's just keep it simple. This function loads the contents of the file with the given path, and then it returns it. The file's contents are returned. If the file could not be read, an empty string is returned. And I don't care if it's a file that's empty, it's gonna be an error for me. It doesn't matter. So this code I copied from is using my file APIs. So we're gonna just copy that. So if we can't open, return nothing. Read the whole thing in. If we couldn't read it, do we want to actually print something? I could say print here. Unable to open file. I guess we'll do the same thing that we're doing down there. File path.cstring. So sure, why not? Return empty string. Why doesn't that not work? Oh, it did work. Okay, and then this is the same thing. That replaces all of that. And all of that. Okay, unable to read, so we don't need that. So it's the same thing. What am I doing? I should have just had the same, just copy it. Okay, and then return an empty string. Assign the contents. What are we doing? Oh, this was to make file contents. And then I guess we're just returning that, right? So I shouldn't just return the string, which is from the vector, and we're done. There we go. I did it. So I can just say const auto script equals load file environment dot script path. And then it's going to give me an error, right? Because it's going to say can't open it, so we need to make one. Just finished watching my yesterday stream. Oh, hi there, retired Android. Welcome to today's stream. I need to actually remember to export my last week's VODs before they expire. I keep forgetting to do that. I'm like a week behind now. All right, I need to make like an example script that we can play with. So I guess we'll just put it in this folder direct. So new file. Foo function foo x. Tell the thing it's Lua, please. Lua, thank you. Return x times x, and then actually, should we have fun and do Fibonacci? See if I can remember how to do Fibonacci. It's like I actually don't remember how to spell Fibonacci, so this will be interesting. Do we know how to spell Fibonacci? I did spell it correctly. Okay, and then Fibonacci is you given two numbers, you return their sum. No, it's if it's just one number, right? And it's like if x is 1, then return 1. And if actually this won't be so interesting because we're just going to have one function, right? We'll just have fun with it. Recursive definition is fun. Yeah. Okay, I can't remember it completely. Let's cheat. Oh, it's 0. Okay, so yeah, I need to have the 0 case, right? If x is 0, then return 0, right? Otherwise, return Fibonacci x minus 2 plus Fibonacci x minus 1. Did I get it right? Oh, they had the backwards, but it's the same thing, right? So then function main would say, I guess, let's say for, I forget how to do a plain old for loop in Lua. How come I can't remember this stuff? For loop. Oh, it's commas. Okay, so for x equals 0 to 10, do, and then how do you print in Lua? Is it just print? I can't remember this. Thank you for that follow, by the way. Let's say Fibonacci of x equals Fibonacci x. End. Let's see if that works. Oh, I need to actually save it. Let's put it... Just put it in the same folder. Example. And then I will say that it's 3 directory levels up and then moon clock example source example main. Okay, right, it didn't run it. So if I... Oh, that's right, I don't have... Okay. I can't actually... I could take it and put it into the... I can do it this way. I can kind of cheat. Lua, and then paste multi-line. Continue. Main. There we go. Is that right? 0, 1, 1, 2, 3, 5, 8, 13. Is that... That doesn't look right. Oh, maybe it is right. 2, 3, 5, 8, 13, 20. Yeah, okay. So the script is correct. I cheated and I ran the main Lua main and just did it. So we want our wrapper to do the same. So we loaded the file, but now I got to load it into Lua. And so I've already done that many times. Let me find, was it here I did it last? Script host. Lua load. Lua load. Lua load. There we go. Right, so it's this junk. Actually, let's just pull this whole thing, and this is a nice convenient function. Actually, I'm going to want the call too. Yeah, okay. All the calls really simple. Actually, the p call thing is nice to have. Okay, so here we're pulling in these helpers. They were stolen from script host class. We don't need them anymore. We're going to want to have a Lua state. All right, and then that is replaced with just Lua. We have a traceback, we have a reader, and the error messages. So with the error message, I think I'm just going to print it. Fprintf, or fwrite standard error. Oh, it's the other way around, right? It's error message dot data, error message dot length 1 to standard error. Done. Okay, that thing is from string extensions. I'm going at 100 miles an hour, aren't I? Hey there, Red Sky 1. Yeah, I think I got the Fibonacci right, right? If it's 0, turn 0, 1, turn 1. I mean, that's what the Wikipedia article said. I guess 0 doesn't always count, so they have it in parentheses. The 0 is omitted in some books. Okay, right, back to here. So call, we're going to want, again, a Lua state, Lua. And then it's just, okay, so the same thing with the error message. We're going to, actually, this should just be if not error message dot empty, print it, right? So we'll do the same thing for a call. Is this really expecting a return value? No, that's the traceback. There are no arguments unless I push them on the stack, and I'm not going to. Okay, cool. So this should just be as simple as we can say, oh, if there is an error, we shouldn't even try to run it. So I probably should return something, right? How about a Boolean? If error message is empty, return true. Otherwise, return false. And then we'll do the same thing for the call. like that. And then that's a bool. Not a boog, a bool. Looks good to me. So then we can just say if script.empty return exit failure. If not load script Lua environment script name script path and script exit failure. If not call Lua environment function name return exit. Actually, I shouldn't be just returning, right? Actually, I could. I can do a little trickery here. So I can say we're gonna use memory, and this guy is gonna be a shared shared pointer. Well, the right way would be to use the unique pointer, but the syntax is a little funny in C++11. We'll do it anyway. We'll deal with the funny syntax. So the way this works is you can construct it from a new state, but then you have to give, I always forget this part. The deleter for C++11 for unique pointer is kind of weird. Yeah, you had to define it like that. You have to define it as a function like that. And then that's the type name, so you'd say Lua state there. And then when you assign it, right, you do one of these things. You give it a function. Actually, otherwise it's the same as if it was a shared pointer. It's just you need to have the second argument to the template. So yeah, just like a shared pointer, it's deleter. It's just a free function that takes it and calls what you wanted to do at the end here. Call, close on it. We even call it Lua. There we go. So then I don't need to have the close on all these exit paths, right? The only downside is that all these Luas have to have a get. Gotta get the pointer out of the unique pointer. No, there's not an error. Stop it. Okay, cool. Let's try it out. Boom. It worked. Only I didn't instrument anything. Fwrite will not be called. You are returning before it. Let's see. It seems to work. It printed it out. Fwrite. Oh, you're right. Yep, you got me. You got me right, hired Android. You got your first point in my stream. Yay! Stream points you can't do anything with other than to brag about it. In the future, since the whole reason of my stream right now is to make this online game, the intent is that you'd eventually, in my online game, be able to redeem points for stuff. But yeah, don't have a game completely done yet. Backcraft's got 11 points. Nice. So did I make that mistake in 2 places? Yes, I did. Wait a minute, how did it work before? Oh, because I was doing load file, and that one it does print before it returns. Okay, we're good. Okay, cool. So now to instrument it. Here's where the fun part begins. So we're gonna make a moon clock, and actually we're gonna share it. So all the stuff I just did with unique pointer, I need to make a shared pointer anyway, which means I don't need to have the second argument. Right? Okay, make the Lua pointer, then we'll make the moon clock. And then I have to make, actually I have to make a clock for it. So, moon clock? Moon clock dot set. Oh, it's in its own namespace, right? So I gotta do that namespace. How am I doing on time? Past 4 hours. I'm on a roll though. I want to at least instrument something. Set clock. So I need to give it a clock of some kind. And that should be a shared pointer. So let's make one. Const auto clock is standard make shared some kind of clock, which we don't have yet. So let's make that up here, struct clock, public timekeeping clock. And then that requires a method, right, called getTime, which we're going to have to override. And I'm just going to use return system abstractions time get time, because that returns a double just like I want. Yeah. As long as yeah. How come it's giving me problems though? Oh, I have to have an instance of the thing. That's right. I forgot that. Thank you for the follow, by the way. Properties, methods. So one property is the time thing, and that time has a get time. And then I have one of those clocks. I set it, and then the fun part is after we load the standard library, and we have to load the script. Before we call it, though, we're the last moon clock to instrument. Wahaha. And we have to give it our Lua interpreter. In fact, we have to let it share it with us. And then we call it, and then we'll stop the instrumentation. And then we're going to get a report. Moon clock dot get generate report, right? Now I got to print something out with that. So what's in that report? All kinds of goodies, right? We have a map from function paths to function information. So let's do a printf report. Before that, let's have a bunch of dashes, because dashes are fun. Yay! Report. I get kind of kooky after 4 hours. I don't know if you noticed that. And then we'll have a dash at the end, and let's make another dash, because dashes are cool, and then we'll have a for const auto function, I guess, in report.functioninfo. What should we do? Should we have it one line each? One line for the top level summary. So like printf %s, and then we'll have the raw numbers. Actually, let's have these formatted nicely. So like, how do you do it? Like, is it like 10 to give it 10 characters? I forget how you do this. And it's like negative to make it left formatted or something like that. I'll figure this out. So the name is function.first, but assembled into like, because it's a vector of strings, I got to join them with dots. And then we have the second dot. Oh, I forgot the number of calls. That's useful. We don't need 10 characters. How about 5, 6? 5 is probably good enough, right? ZU. So calls. No, num calls. We haven't done calls yet. Num calls, and then min time. Let's do max time next, and then total time divided by num calls will give us the average, right? And let's go ahead and print a nice header for in front of this, right? So instead of that, we'll put strings. This isn't probably not the best way to do it, but replace that with a space, and we put function number calls. It's got to fit into 5 characters though. Number. How about just number? Min, max, average, right? And then print that out. Let's see what I get. I messed up something. Syntax error. Ooh, 341? What did I do? Shoot. Where is the Oh, is that because I need a colon there? A semicolon? That's not right. What am I missing? That is what I need. I get confused. I work on 3 or 4 different programming languages, and I'm like, is this one of the ones where I need a semicolon at the end? Okay, it's not formatted very well. Oh, because I didn't format the name nicely. Let's give that one 20 characters. Oh, and I need to put that in front of the 2, don't I? So there you go. The numbers don't look really nice. What? It's because they're so small, actually, and I need to give them more spacing. So let's make the 10s a little bit bigger. How many more? Like 14? Okay, so Fibonacci. Oh, the colon's way over there. I guess I don't really need the colon, do I? Let's remove it. Fibonacci got called 453 times. The average time it took is that. We also called main once, we called print 11 times, and we called toString 11 times. Isn't that cool? Because Fibonacci called print. So the next thing would be for every function, let's list the other things that it called. As like a second layer or something. Maybe just indent it a little bit and reuse the number and what if I added in addition to average, we also printed total. Total. And print another one of these 14 Gs. And so then I can reuse that in the subordinate system. So for const auto subfunction in report in function.second.calls, we're going to print more things, right? Only not all this information. I chose not, iGrok recommended I do recursively, and I took that into consideration, but I chose not to do it for now, but it's here in case I am proven wrong. Instead, it's just 2 levels, and it's the functions that are called by each of these functions, and it has a little bit less information. It just has the number and then the total. So for this, let's indent it a little bit. Let's say 2 characters, and then so we've taken 2 characters off of that. And then we'll keep the number, and then these are just filling in with blanks. Minimum, maximum, total has something, and then so this is subfunction first, subfunction. So some of these don't actually exist, right? So all the ones that don't exist get replaced by an empty string. Right? And I don't know, let's see what we get. Oh, look at that. Fibonacci called itself 442 times. So we can see the difference between these two is not important, is it? Because it's recursive, it's kind of hard to tell how much of the time is in Fibonacci itself versus how much is in the recursive calls, because it is itself, right? So that's one thing that's going to be difficult to make any use out of that number, right? But yeah, you can see the total time it took 27 milliseconds to run. Of that, 22 milliseconds is Fibonacci, and that much of it is print from main. Main calls print? Is that what I did? I thought I had Fibonacci call print. Oh, maybe I did. Oh yeah, that's right. So there we go. Main calls print 11 times for that much time. Print ends up calling so this is what's really cool. ToString is an internal thing in Lua, and because it's everything that I can get to is instrumented, so is ToString. So we know print called ToString 11 times, and that's exclusively from print. So I could actually do a reverse map. For every function, I could say who called it, and then ToString would list out print, Fibonacci would list out main, and print would list out main as well. But I don't think I'll get to that because I'm kind of tired. I think this is a good demonstration. If someone had a more interesting Lua script for me to try, I could run it and totally get cool metrics. The other thing I can do is make a release build of this and run that. Would that be fun? Compare debug and release builds? So I happen to have that build setup. That build configuration, I mean. It's called VS, and I can say cmake dot, and then I can just run as soon as it's done. As soon as it's done. You always dislike the way small numbers print with an exponent. We can fix that. I figure if it's an exponent, it's like either really small or really big, and I don't care about those numbers. So I glanced, I'm like, oh, okay, most of it's in print, and there's a little bit, like tiny bit in toString. That's how I read that. I'm getting more texts. Oh, the car is okay. They need a new gas cap. Huh, okay. Okay, my car is fine. Mrs. Reimer says it's just the gas cap that was bad. You don't like the way it looks, but it's mathematical. Well, you would probably like it better if it was like space times 10 to the power of -5, right? Yeah, I understand. It's kind of funny because you have to look for the E. Maybe if it was print with the E in front or something? No. How would we force it to print it the other way? Is that just... We'd have to give it a fixed precision. Let's try this. So the LGs, right? All the LGs would be instead LFs and then a dot. Let's go out to 6 places. Let's say we don't care about more than that. There we go. That looks a little bit better. Actually, we can get more precision. Let's give it 8 decimals of precision. Why not? Because we can. We can go out to the... How many is that? Nanoseconds or something? Just because we can. You must have used a ton of printf in my career to have the syntax memorized. I used enough of it. Let's just leave it at that. Okay, see you, Backcraft. I'm almost at the end anyway. So you won't miss much. We could reduce the number of characters I have here, right? The 14s could be something smaller. If I was really good, I would use stars and then have the 14 be a variable. But I'm not that good. I just know that you can use star in there. Instead of having a fixed width as encoded, baked into the string, you can actually have it be an argument. See, I'm getting the report down to something that I like to see now. Min, max, average. It's looking good to me. A number. I want to right adjust those though, I think. So that is just removing those, right? And then I want more space to the right. So there, and there. I really love multiple cursors, by the way. And then more dashes. Must have more. How many more dashes should we have? Lots of dashes. There we go. Really, I should have the dashes go all the way for maximum effect, right? 3 more? There we go. If I was really pedantic, I would have vertical lines too around the report. Okay. Right, I was kind of stalling because I wanted this to generate the Visual Studio project. With the Visual Studio project, we can, I have a release build I can make. So I'm just gonna tell it to build that right now. Build it. And what's cool about CMake is I don't have to worry about setting up anything in Visual Studio. It just builds it. So now, instead of being in this directory, actually, do we want to do side by... I'll just do a relative path. Dot, 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 build vs. See if I can get this right. It's rel... I lost the rest of my command line. I hate it when that happens. It would be example from there, right? Maybe it's rel at this point. No. Is it like this? Yes. Exactly. Okay, and then the rest of this. Link. There we go. Okay, maybe remove these prints. It's hard, sort of hard to see them side by side, isn't it? I guess I can make my window taller. There we go. So the debug build took 21 milliseconds. The release build took 5 milliseconds. So like 4 times faster. And actually most of it was in the print. Fibonacci itself runs really fast. It used to take 84 milliseconds. Now it's only 1.6 milliseconds. So I wonder how much faster even LuaJIT would be. And I don't even know, would I be able to instrument LuaJIT? I have no idea. Maybe. I/O is slow? Yeah. I imagine that's what's the bottleneck. So what's cool is that when I instrument it, I can actually see how much the print contributes to the total, and I can neglect it if I only care about Fibonacci. Well, there's the number. Although there's something wrong here. That's wrong. Main should only call Fibonacci 1. Oh no, it calls it 11 times. But why is this total not the same as that total? Do I have a bug? I wonder if I have a bug here. Or maybe because it's recursive, it's counting into itself, and that's the real number? Sure seems like a bug, doesn't it? Shouldn't that number and that number be the same? Or that number and that number, shouldn't those be the same? I wonder if it's something with the recursion. Because the print number matches, see? That's not recalling anything else. Actually, it's calling toString. Yeah, so these all match. I wonder if the way I'm doing the recursion, maybe the numbers aren't right because of that. This is probably the real number, and this number right here should be that, and it isn't because I messed up somehow. It's probably double counting the recursive calls. I bet you that's what it's doing. Oh, wait. No. I'm just getting confused. I think that is a bug. What would cause that? I can't think. I need to go eat something. Okay, so I'm going to probably debug this later today, but I'm really happy because the core stuff is done. I can instrument any Lua stuff I want. I'll check this example in. The example is really simple, I think. It is when you have a Lua interpreter and you load your script, you just call start, and then you do your thing, then you call stop, and you get a generate report, and then you can format it however you want. And the start instrumentation does all the work about finding all the functions and instrumenting them, and then we have some go to declaration, please. We have some default instrumentation, and that is keeping track, kind of mirroring the call stack and measuring times using a stopwatch kind of thing, and counting the total times and total numbers of calls and all this good stuff. There are 2 places where that's done, right? Right there and right there. So there's probably a bug in the instrumentation functions where when it's recursive the numbers are wrong. I'll have to think about that. So I'll fix that bug, and then the last steps I guess would be like the plan said. I need to be able to instrument non-tables, so that'll allow me to instrument stuff like the Lua functions that are actually C functions in my game engine, and then figure out how to report it from the game. Probably we'll collect the this report, I guess, upon request. I'll probably have commands that I can do from the admin console to start, stop, and generate. Probably stop and generate will be pulled together. And I suppose we would probably take this report and turn it into JSON and send that back to the client, and then the client could then just like these C structures here, the function information and calls information really is just 2 levels of structure that we can turn into JSON really easily, right? And just put that into some kind of tool. I'll probably do it in Python. And then I'll run it with the test environment, and then I'll probably verify that all the pathfinding is super slow. And then I'll have to look into what parts of the pathfinding are slow and maybe get into some insight about what I can do to speed it up. So that'll be Monday. I think I'm done for now. I hope you enjoyed watching the stream. So this will probably be one more day of Lua stuff, and then we'll probably be getting back into I wanted to do another side project, which was 2 days ago. Yeah, so this idea from Toulouse that, let me show my game again. So my game is starting to make use of pathfinding. When it comes time to move these NPCs around, where they think they can see and move is going to be using pathfinding algorithms. So the algorithms that the pathfinding algorithm blog that I learned from looks like this. So what I really liked about this blog is that it had these interactive it had interactive feedback so you can see what's going on, right? How the search works and stuff like that. And especially when it came time to showing you the differences between the different algorithms and how, like, if you place the destination in different places, how it computes, you know, which squares it actually considered and what the internal cost metrics were. So the idea was that in my game to show a similar kind of thing, so you could highlight George and then it would show you all the tiles, like with an overlay of some kind, showing you how much it would cost George to move to any of these adjacent squares. And so that's going to involve a lot of C++ work as well as JavaScript, because we have to collect the information about the different tiles and their costs and give it to the rendering system. And then the camera has to subscribe to that, and then the rendering and the JavaScript has to have some kind of sprite overlay. So I'll be working on that soon after I get enough of the Lua stuff squared away. So that'll be next week. Let me go find someone to raid now. Let's see who streams right now. Some different people. Did I raid Zeratar recently? I like raiding him because he's working on a fun little stream integrated game. Yeah, let me just check to make sure he's not ending or something. I gotta watch an ad. So I'm probably gonna raid Zeratar. He's another dev in the live coders.dev is the team of Twitch streamers that I'm in, and he's another dev streamer in live coders. He's working on a game which is integrated into a stream. So while you're watching his stream, you can do chat commands to have an avatar representing you go into his game and do different things like train and craft and raid and all sorts of interesting things. And it's all written in Unity, C#, and he also has a lot of other interactive features in his channel. So he's a great guy. I hope you enjoy it. And I guess I'll just hope you guys enjoy that, and I'll see you on Monday. Hopefully, maybe. So thank you. See you. Have a good weekend. Bye.